No, I was just.
I don't know if you should leave.
It's gonna be like
It's answer time.
There's snacks at top and
Wait, really?
no, seriously.
I'm the opposite.
No, whenever I meet one of my friends, like, so I have questions.
I'll sit here and craft. I'm just making plays with this radiation. Well, not actually.
So, no.
Usually that's what nitrogen is.
What is this?
So you go on a spiel that'll last about 5 minutes.
What is it?
It's a fish. I always think someone
So how do you start me? What do you say? Like it's so Yeah, so we'll have a podcast. And I stood like near the and I still inside. Looking at between everything. I was like, oh no, I was curious.
Now we're gonna get started in about 2 minutes, so if you wanna grab some snacks, make sure you have a booklet. If you haven't picked one up, grab one. It's situated.
She was like,
I'll stay for here. I'll sit for each side.
I feel this one. That was
I was looking forward to meeting
that's fine. That was like, so if you also so.
Yeah, that's what I did.
Yeah, let's just start with something.
Okay, no, that's good.
All right, folks. Good morning. How y'all doing? Hope you're well. I'd like to. My name is Frank Jordan. I'm the chair of the Department of Biological Sciences, and I'd like to welcome you to the 34th annual Undergraduate Research Symposium. I have a few things I just want to real quickly mention on this introductory slide. The first I already said, 34 years. That's pretty amazing that we have sustained this, I would call one of the preeminent events on campus, all right? Most prominent events on campus that showcases undergraduate scholarship in collaboration with our faculty. All right, so 34 years. When Hurricane Katrina came, next spring semester, we had this undergraduate research symposium. When COVID shut down the world, the following spring, or that spring, we had online, but we had it, the Undergraduate Research Symposium. Through that whole damn baby shark thing, dude, we kept doing it. So we've overcome lots of hardships and disruptions. So that's the first thing, obviously, I want to mention. All right. The second thing is that the biology department loves hosting this event, but the thing we're doing more and more is saying that we're hosting. It's not strictly a biology department event. A lot of our faculty collaborators are from chemistry, physics, neuroscience program, a relatively new neuroscience program, psychology, etc. And a lot of different departments, a lot of different faculty work on questions relevant to the life sciences. And so we're happy to host all these students and be kind of the umbrella event to present their undergraduate research. One other thing I want to mention on this slide is that if your parents are here, your family's not here, your friends are here, and they wanted to see what's going on, well, this QR code right here, you can scan in, and we are streaming this live on YouTube, right? Yes, on YouTube.
Loyola University Environment Program YouTube channel.
We're going to have the comments on up next to the speaker's slides so they can see real time. No, I'm kidding. So, why is Loyola special? You know, today is an important day. In addition to our undergraduate research symposium, it's also a Wolfpack preview day. Today's a day that we're recruiting new students for fall of this upcoming fall semester. And you know, when you're trying to decide which university you want to go to, there's obviously a lot of factors. I don't have cost up here, I don't think. But, yeah, that's wrong. But anyway, that's for the parents. But we're Jesuit, we're Catholic, and all the values that it entails, including commitment to social justice. You're going to see a lot of talks in the first section this morning talking about some of these things. Obviously, people are attracted to New Orleans. It's a great cultural mecca. Wonderful music. We've got the French Quarter Fest going on, getting ready to have the Jazz Fest, et cetera, et cetera, et cetera. We have a relatively small size number of students in our university and a number of faculty, and that means that the students are able to interact with the faculty on a regular basis. We don't have graduate programs in the sciences, at least, and so that means these students are our grad students. For better or worse, we're using you to help us get our research projects accomplished and complete. So, we have this wonderful engaged students that are going to be presenting today, and for the science nerds, I've reduced this to a formula, and this is a formula for successful conduction of undergraduate research. So today is special for our students because this is the penultimate step in their journey towards becoming young scientists, all right, and completing their honors requirement. And I say penultimate as a gentle reminder that I need your thesis signed by your advisors. I haven't May 5th yet, but I think it's May 1st, actually. So there you go, May 1st, all right? So by May 1st, I need to see your signed final version. What you think is the final? It won't be. All right. So today we have a total of 22 speakers, same as last year actually. A total of 22 speakers that are going to present research from a couple of semesters or many years, several years that they've been working on. So this is the culmination of quite an effort that these students have been investing their time, energy, and effort into. So I would like to take a moment to go ahead and thank them. Now, I'm sure we're going to applaud them over and over again today, but let's just do it one time to get started, all right? The week of graduation, there's going to be the biology department award ceremony, and we're going to announce some awards, but most of you won't be there, so actually I'm going to take a little liberty, and I'm going to announce this year's recipients of the biology department awards, because it's no coincidence, every one of them is also a presenter today. All right, these are students that have just shown excellent academic achievements and commitment to supporting the Department of Biological Sciences. The first award, I'm just going to abbreviate these, is our Faust Award for the highest GPA, and David Eaglehart is our recipient of that award this year. I like to put people on the spot. Our Pignatelli Award is, it's got a lot of different meanings, but it's somebody that really shows a commitment to our department, in addition to academic excellence. And our winner recipient this year is Kathleen Coolidge. There's an award that goes across the natural sciences, so all the different departments get to nominate winners for this award. Our recipient and winner this year is a biology major, David Eaglehart. In December of this past year, we had a very unexpected death in our department. We lost a valued community member, a wonderful teacher, Dr. Royal Saunders. So we have created a new award and to celebrate the best student using several different metrics in anatomy physiology course, all right, across both sections, lectures, and lab. And our recipient this year is another one of our speakers today, Isabella Leon. Okay, we have a lot of faculty that have committed a lot of time, energy, and effort to supporting the research, of these students. All right. There are faculty on campus, but there are also research collaborators off campus at LSU, Tulane, and other research institutions. So let's give them a quick. Thank you, parents, for sending your children here and your money. And the rest of your family members who have supported you and your friends who have supported you throughout this sometimes stressful process that research can be. All right, so let's thank them. Research ain't cheap. All right, and so we have a lot of different benefactors who have helped support our research. Two that I'd like to point out especially today are the Malahi Fund, which alumni and other donors have generously contributed to over the year. And each faculty member has provided a small amount of money each year to help subsidize undergraduate research. And then more recently, the Gene DeKernian Fund has funded a lot of the students that are presenting their research today. But there are a number of other institutions, agencies, organizations that provide support. So thank them. All right, so today there are some strange-looking people in our midst. A lot of them are actually our alums. All right, they graduated from our biology and other life science departments. Don't say stranger danger. It's okay. We know they're here. they're judges, and they will be evaluating the talks and presentations today. And indeed, the scores that they generate are one of the metrics that we use to assess how good a job the faculty are doing. Just like you have tests and exams and quizzes, this is our assessment, or one of our assessments. All right? And hey, you guys have been doing great over the years. There's actually a statistically positive increase over time in how well these things are judged. Oh, I'm sorry. Let me just use this as an opportunity to tell the speakers, and I probably should have told you this before, but I think Dr. Thomas shared this with you. The talks will be evaluated on their objectives, organization, understanding, their responses to questions that they receive from the audience, their sexy graphics like this, the mechanics of the talk itself, and fortunately I'm not being graded on this, your elocution. So we have a few judges here, so let's thank them in advance. And let's thank Dr. O'May Thomas and Rose, who's hiding up there, for doing all the hard work. So during the breaks, there's snacks, there's food back there right now, unless they ate it all. And then we would like to get all the speakers together, if possible, around 2:30 for photos. All right. And then at 5:30, there's a crawfish social over in the Peace Corner. All right. That's it. Thanks for attending.
All right, so just a few logistical things for today. The reason I was encouraging you to step over here, because we're streamlining it, this has you in the view, and I know your relatives want to see you. It also has the screen. So it's not like Zoom where it's just showing the screen, it's showing the room at a certain position. So just to let you know, if you want to project like we're projecting, you don't need a microphone, but if you want to use a microphone, if you're nervous about your voice or anything, we have two. So just let me know when you come up here that you'd like to use a microphone. We also, for the speakers, we have a pointer you can use that has a laser and advances the slides. So just make sure you get oriented to that when you come on up here. So it's just a few logistical things. As far as timing, we've given you 12 minutes for your talk and 3 minutes for Q&A. So I'm going to be the bad guy, keeping you on task, hopefully. So when there's 3 minutes left, I'm just going to wave this from right over here to let you know, start wrapping it up. 2 minutes, 1 minute, and at 0, I'm just going to come grab you off and we're going to move on. Because, we need to let the next person go. We want to try to stay on task as much as possible because people are timing their day to be here at certain times for certain talks. The food will be replenished during the break, so do know that if we are running low right now. So for the first set of talks, Dr. Bucalo is going to introduce you, and I'll get your PowerPoint set up, so let's roll.
All right. Thank you all for coming. The first session, the first talk, we're going to have Ty Murphy, Jackie Mutter, Katie Buck, and Hillary Wynn talking to you about the Loyola Scholars for Environmental Justice, Sustainability, and Resilience. And that will get us going.
Hit the right arrow and make sure it moves. Okay.
All right. Hi, everyone. We are the Environmental Justice Scholars for this semester here at Loyola. My name is Hillary Wynn. I am a double major in theater arts and environmental science with a concentration in biological sciences.
My name is Jackie Mutter, and I'm an environmental studies major with a concentration in humanities.
Hi, I'm Ty Murphy. I am an environmental studies major with a concentration in humanities and a minor in sociology.
My name is Katie Buck. I'm a double major in political science and environmental science.
Great. So first off, what is the Environmental Justice Scholars Program? This is a program that's very kindly funded by Entergy, and this program really allows students within the environmental science, environmental studies realm to dig into personal passions and create projects of our own we are all required to have a community partner or faculty mentor. So you are able to create your own projects and work with a faculty mentor or reach out to an organization within the community as well. Again, it's very kindly funded by Entergy, and we are each, we all have to complete at least 90 hours for our various projects, and we also have to work at least 75 volunteer hours as well. The aim for this program is really to help bridge the gap between everything that we learn in our lecture-based classes, lab-based classes, and really bring that into the community in the greater New Orleans area.
For my personal project, I looked at the connection between art and spirituality and the environment, and my collaborator was Ty Murphy, and our mentor was Dr. Daniel. And our research was qualitative research in the form of semi-formal interviews. So we'd interview various individuals in New Orleans and Louisiana who had some type of connection to art and spirituality and also to the environment. Prior to every interview, we would do research on the interviews so that we could understand what they do and their art form or their spiritual practice and the work that they do in their communities. And then during the interview, we would record them so that we could transcribe the information later. This is a project that we've been doing since 2021. So in past semesters, we've interviewed Kathy Randalls, Sula Spirit Evans, Monique Verdon, and Sharice Harrison Nelson. And this semester, we got to interview Sharon Levine and Paris Sion. Sharon Levine is an environmental justice activist who works to stop petrochemical industries from coming into Cancer Alley. And she connects to spirituality because whenever she is losing hope, she turns to her faith, and that gives her strength. And she also will turn to the Bible to give her the courage and the strength to do what she does, because it can get a little discouraging when you're in this line of work and you're seeing little to no results and you're talking to all these people that are suffering with cancer. Paris Sion is an artist of many different art forms, and lately she's been focusing on dance choreography, which she calls movement architecture, and she connects all of her artwork to the environment in some way, and she views her art as a veneration to the land, and she hopes that all the art that she does can give honor and remembrance to the land and bring awareness to environmental issues. And lately she's been getting inspiration for her movement from the movement of hurricanes. And Ty's going to talk a little bit more about her project now.
Just to piggyback off of what Jackie said, the research that we do conduct with the interviewees is done through our digging and diving into different online resources provided by the library, as well as social media accounts. We've done articles as well as magazines, just to gain knowledge and insight on these individuals, to ask the proper questions to relate it back to art, spirituality, healing, and environment in New Orleans as well. Recently we interviewed Paris, as Jackie mentioned, and I noticed that the research that we did conduct with Paris, it took a little more digging and diving because a lot of her information was like videos. So we did watch the videos of her dancing, and that was kind of, she didn't really speak very much. So we had to really dig and dive to gather that information, as well as the previous people we have interviewed. They were mentioned in newspaper articles, magazines, online, in like news, video clips, and things like that. So we really pay attention and we focus on interviewing the people in New Orleans that we gain through connections through prior interviewees, or we also do it through Dr. Davis, who's really great at finding us people to interview, as well as recently Paris mentioned some other faculty members from her university she attended, as well as her family that she think will be great people for us to interview in the future.
Alright, so for my project, I was able to partner with Recirculating Farms. They're a local nonprofit in the area, and they have a focus on policy advocacy, food access, as well as education for community members. I got to work hand in hand with their programs manager, Dimitri Sellis. So during my time at Recirculating Farms, I really learned a lot about what goes into the front end of building a program for a nonprofit, as well as learning more for community outreach. I worked with them in order to start a new program that's currently in development called Food Forward. It's a program that plans on diverting food waste from various places such as restaurants, bakeries, other community gardens as well, and trying to divert them from going into the landfills. Other than that, I also went to various outreach events and was able to research and read up a lot on various methods used at outreach events to reach different audiences, different age ranges, and things of that lot. In my other side of working with them, I also was able to work on outreach through being a farmhand. So every week I was either on their urban farm in Central City every Tuesday or every Saturday. During my time with them this semester, I've been able to work with over 20 volunteers on the farm, which has been very nice. And all of the work that we have put into the farm has accumulated into over, and this is a statistic I just got yesterday, over 1,100 pounds of food in the past 3 months harvested to go into various avenues to give food back to the community. So yeah, goals for the future, we have goals to further develop food forward, as well as engage in more audiences and reach more people through various outreach events.
Hello, my name is Katie. My project focuses primarily on expanding the sustainability initiatives and programs here at Loyola, as well as an extension of my project from last year, which focused on litter cleanup and waste reduction. With the work I put in last semester and the help of a former faculty member, Jordan Jones, over the summer we received our Keep Louisiana Beautiful University Affiliate status, which allowed us more access to grants and networking with other universities, a part of that program. I had two collaborators this project. One is Mark Tobler, who I assist with the Keep Loyola Beautiful program that we have and our litter cleanups, as well as under the direction of Jacob DeBrusha, I am a student leader of LUCAP, which is Loyola University Community Action Program, which allows us to work with our students and community members to do volunteering, such as beautification efforts and just environmental volunteering overall. Through my project this year, I have organized 5 events total with 153 total volunteers and 296 hours overall. 2 of those projects included the World Cleanup Day, which we collected 176 pounds of litter at the flyover by Audubon with the help of 71 volunteers, as well as the LUCAP Wolves on the Prowl cleanup that we did with the Alumni Association. This past year, Mark Tobler applied to the Keep Louisiana Beautiful grant, which he received, and we got money to enhance our recycling on campus, which included implementing 5 new trash/recycling receptacles in Monroe Hall, and glass recycling that is now available on our campus to our community members and our students. Prior to our installment of those receptacles, I completed a pre-recycling audit, which found that only 56% of the 198 pounds of material I found in Monroe was actually recyclable. And we also completed the Keep Loyola Beautiful litter survey, which collected 21 pounds of litter with the help of Dr. Del Bianco's Foundation of Environmental Studies class. Graphs for those 2 data are found in my project back there. One of the other posters. I wish to continue my project in completing a post-recycling audit to analyze how effective our recycling and trash receptacles are, as well as a Love the Boot cleanup, which will happen during Earth Week, and a waste audit to analyze what kind of waste Loyola is producing and how we can properly to see what waste we're producing, as well as just to understand what the waste our students are giving away, such as like containers with content, which is like they're just throwing away their food. And it's an entire waste, and it's really upsetting to see from our community. And the Woodpack Move Out Donation Drive, which will happen during Move Out later this semester, which is open to the community to donate products and materials that can be given back to our community, as well as our Loyola community, as well as our New Orleans community. And Ellie Redeman is in class right now, so she isn't able to join us. But her project focuses on establishing a rotation of fresh produce to donate to Iggy's Cupboard, which is Loyola's food bank, throughout the year, and develop a volunteer network to engage students from all majors. So she is, as well as providing the fresh produce, she's engaging students and community members through growing food and teaching them about the environment. She is maintaining and harvesting the garden beds that was established by other environmental justice scholar Hillary in 2020. She tracks the donations and determines what produce our students most would prefer. And she has implemented on-campus compost pickup, which is available on a Wednesday and is available to all of our students as well as community members around us. And with the help of Jackie, our other environmental justice scholar, she is organizing field trips and volunteering events with Students for Environmental Action, which is a organization here on our campus that engages students with environmental volunteering. And with the rest of her project, she wishes to expand these garden beds to the top of West Road Garage, as well as develop a recipe book for produce to make it more accessible to our students.
So lastly, what personal impact did this have on all of us? For me personally, working with recirculating farms, I think it's really shown me the importance of nonprofits in any community, but specifically the greater New Orleans community. And as a graduating senior, I see myself following steps and going into the nonprofit sector. So having this opportunity to see what I like and what my passions are in that specific field, it's really nice. Looking forward.
For me, this project has impacted me in a lot of ways, but one of them is that it has taught me about connections to the environment that I hadn't previously thought were there, such as the connections with art or spirituality. It has also taught me a lot of valuable qualitative research skills and how to conduct interviews, and I can take those skills with me and use them later on in life. And it has also provided me an avenue to reach a greater number of students in the Loyola community to get them involved with environmental issues through Students for Environmental Action, whether that's volunteering on campus in the garden beds or in the greenhouse, or off campus with local environment-related organizations.
The impact that this research project has had on me, it has created an atmosphere where I'm able to develop my passion for the environment, as well as social justice, being an environmental justice scholar, as well as a social justice scholar on campus, as well as it has allowed me to network with different individuals through my research. I started off as a social justice scholar. I was able to move forward to an environmental justice scholar, which has led to me to working with different organizations such as SONOLA, as well as CRCL, the Coalition to Restore Coastal Louisiana, which has led me to meet Paris, a person that we interviewed this semester. So continuing this research project and going forward, it has allowed me to network and meet great individuals in the New Orleans area.
I've loved to see the impact that we as individuals can have in the environment and the community around us, because it's really hard to see what we as individuals can do to help the environment as it is so vast and wide, and it's really amazing to see what we can do. We would love to thank Entergy Charitable Fund for providing us with the funds to continue with this project that we are so passionate about, as well as our collaborators and mentors, and all the volunteers that have helped us along the way. And Students for Environmental Action, and Dr. Nate Thomas as leading our project, and for the mental support, Steve Irwin. So, thank you.
We have about a minute for questions, if anybody has a question for the EJ scholars about their research.
Yes.
Leah.
Compostables, when you see a receptacle that says compostables, what are we supposed to put in that?
It can be food and veggie scraps. It can be food and vegetable scraps. Normally, people don't allow meat and dairy products for composting, but we have a partner who picks up our composting. It's Schmelly's, and they actually also allow us to collect meat and dairy products. So they say anything that once was living, we can compost. And so you can bring it, throughout the week, you can put your compostable stuff in our freezer, in a paper bag or reusable bin, and then on Wednesdays you can bring it and drop it off. And it's open to anyone in the New Orleans community, not just students.
Yeah, it's also an advertisement, but at the joining of spirituality and art, next Thursday, a week from yesterday, we're going to have some of the folks that you talked about are going to be on campus for the roundtable at 12:30 in 610, I think, 610 room. So, and I just on that, I wanted to ask, how do you preserve that, right? So it's an oral history. Do y'all have ideas about how that's going to be preserved for the future, or how's that going to work?
Yeah, so we record the interviews, like I mentioned, during my slide, and then we transcribe the information. So anything that they say related to the environment or environmental justice, or we can save that to look at it later. And then after every semester, we write up a paper and send it to Dr. Daniel. I know that Dr. Daniel originally wanted to continue doing this research. I'm not sure if she still is, but.
Thank you. And during the break, you can ask them more questions. How about that? Does that work?
I failed to mention that all of our environmental scholars are overseen by Dr. May Thomas, as well as all of the other mentors that they discussed, such as Ann Daniel and Marianne Grafone and Mark Tobel. For our next speaker, Leah Bazan will be speaking to you about the association between STEM attitudes, growth mindset, and math and science performance, and her mentor was Dr. Madison Silverstein.
All right, good afternoon, everyone. I'm just going to get right into it. All right, so some background about this topic. I just want you all to know why this is important. Academic achievement, as many of us know, is very important to STEM fields. Many STEM jobs require higher education, whether that be through certificates or degrees, licensure. Higher education requires standardized testing, even if your institution is test blind. Most likely in high school or some other school, you've experienced standardized testing. So it's important for us to measure academic achievement with standardized testing. And finally, our conclusion from this is that high academic performance plays a large role in obtaining STEM jobs. So, growth mindset is one's belief in their potential to improve through dedication, hard work, and effort. This is why you want to encourage your students to study for a test days before, because they believe that they can improve themselves. So when we refer to a positive growth mindset, this is a belief that you can improve yourself through working for it. And psychologist Carol Dweck popularized growth mindset as an avenue to academic achievement. She has many TED Talks on this, but it was popularized for all these educational programs in her 2006 book, Mindset. So after she popularized this, these programs became very popular in schools and other educational settings. Many of you, who are in college right now may have experienced one of these programs. So research has shown that growth mindset programs are successful at increasing the growth mindset, giving you a more positive growth mindset, but research on its effects on academic achievement have been largely inconclusive. Some people find that they do, some people find that they don't. So, subject attitude. This is your attitude toward the subject, how you feel and how you think about that subject. Think to yourself, do you like math? Do you dislike math? You're going to have to do it at some point. Everyone has different feelings towards different subjects. But there's little to no subject attitude research as it affects academic performance. But what there is research on is STEM. As you've all probably heard of and seen, STEM, people are promoting it because of all the job growth and all these things. So what we have seen in research is research on the implementation of programs in childhood to influence children to STEM fields later in life. These are in elementary schools, general things like that. We've also seen research on the creation of programs for young adults to increase their interest in STEM and influence them into STEM and higher education. And all of this research has shown that promoting a positive look on STEM does help people feel more comfortable with it and go into it later on in their life. And just some more background research. Other attitude research in education has just focused on general educational attitudes, but it hasn't been specific. This research has focused on, if you like school, are you more likely to stay in school? Very broad things like that. In research, it's generally been assumed that positive attitudes will increase your performance. Now, the goal of this study is to better understand the relationship between growth mindset, subject attitude, and math and science performance. We did this by investigating if a subject attitude or growth mindset had a greater association with academic performance. And to do this, we formed some hypotheses. The first of which we said the higher the growth mindset, the more positive the attitude towards the subject, the higher the performance in that subject. And the second of which, the attitude towards a subject will have a greater association with performance in that subject compared to growth mindset. Now, I'm going to talk about some of our variables, and these are in the order that we placed them on in the survey. Academic performance. We tested this with some publicly available ACT practice questions. If you've ever taken the ACT, you know that you can just look these up and they are available to you. So we just pulled them off the website. We had 2 sections. One was a math section, 5 math questions. One was a science section, 5 science questions. And this was very important to us that because we are testing this on a college sample, and we wanted students to have some prior knowledge to be able to answer these questions correctly, but still to make enough to make you think. So, this was important. Second, we measured growth mindset. We used the growth mindset inventory created by Dweck in her paper. And it's a 10-item Likert scale questionnaire, and it just asks you different negative and positive questions, some of which, I feel like my intelligence is set in stone. I feel like I can promote my own achievement. Things like this. And finally, we measured subject attitude using the Attitude Towards STEM survey. And these are questions pertaining to math and science attitudes. It was developed for high school students, but we adapted it slightly for a college sample. This was 2 sections, math and a science section, which kind of did the same thing as the growth mindset questionnaire, but it was a little different because it asked you questions about I feel like I can achieve in math, I like math, things like that. And just to note, for our data, we had a validity question at the end, which we made sure, but we asked people if they use any outside sources for the math and science ACT questions. So, our method. This was a self-report survey on Qualtrics. We had 127 participants, and we had a fairly good breakdown of ethnicity, but it was a very female sample, with 76.8% of the participants being female. We obtained consent, and only the investigators handled the data. And for the data analysis, we did use a regression analysis. So our results. Both growth mindset and subject attitude had a significant overall effect on math and science performance. But when we went further into these results, and when we examined individual variables, only subject attitude was a significant predictive of performance. So when we saw this, we went in a little further using the data we had, and we found that subject attitude actually had a stronger effect on science performance than math performance. And these are all some fairly interesting significant results. Now, what does this mean? What do these results mean? This means that subject attitude may have a much larger role in promoting academic performance than growth mindset. And this is very important for us to know because, as I mentioned earlier, there's a lot of growth mindset program implementation in schools, little to no research on subject attitude, and if one looks like it's going to affect more than the other, then we might need more subject attitude programs in schools. This also shows how relevant STEM programs are for encouraging students into STEM fields later in life. If your attitude is affecting it if your attitude is affecting your performance, and these STEM programs are affecting your attitude, one goes into the other. Yeah. And this also means that we might need increased focus on promoting positive attitudes. Another thing, growth mindset programs may not be as effective as we previously thought. As I mentioned earlier, these programs are popular, you might have experienced them. And research has been inconclusive, and especially if you take this data into consideration, we may need to reevaluate our perspective on those. And finally, subject attitude may affect different subjects differently. So there would be different needs for different programs, depending on if you're a math program, science program, depending on what your subject, what your purpose is. Now finally, some strengths and limitations of this study. We had a very good ethnic breakdown. So, good. We also had a fairly good sample. We needed 50 participants, we had 127. The relevance of this research for education and for influencing students into these needed jobs it's very relevant and needed. And also this is, to my knowledge, one of the only studies of its kind investigating specifically subject attitude, growth mindset, and academic performance. Now, the gender breakdown was not that good. We did have a much larger female percentage than anything else. And this was self-reported data, so it has all the issues that any other self-reported data would be. People can report incorrectly, all these things. And although we have asked a validity question, there's no way to ensure the ACT question's validity in this study. So future research. We need more research into subject attitudes and their effect on education and performance for all the reasons I said before. STEM programs' effect on performance in STEM fields. We have some of this, but especially considering the results of this research, this would be an interesting thing to look at more. And finally, gender differences in subject performance. We did find that gender was a significant indicator of math performance, but not science performance. But because of the skewed data with gender, with having such a high percentage, we didn't want to include this, but I figured it would just be something interesting to put in. And finally, I want to thank my research mentor, Dr. Madison Silverstein, for all of her effort and support in answering me. And also to Dr. May Thomas for supporting me and helping me throughout this whole process. So, thank you.
We have about 2 minutes for questions. So questions for Leah?
Is any incentive provided to take the survey?
We did not provide any incentive, but the psychology department does encourage students to take these surveys by offering extra credit, but that's volunteer. So that was pretty much the only incentive there was.
Actually, I have a question. So in your hypotheses, one of your hypotheses was that attitude was going to be more influential on performance than growth mindset, and I was just wondering why, before you got your data, you thought that might be the case.
Well, so as I mentioned, the growth mindset research that we've had has been inconclusive, and we do know from prior research that attitudes have a significant effect on, how you act and behave. So it was kind of just an educated guess in that aspect of. We have no research to go off of, but we know that attitudes do this in other fields, and that growth mindset is being inclusive. So
Any other questions? Okay, thank you, Leah.
no, we've got a full minute.
Test, test.
So for our next speaker, you might recognize her from our first talk. We have Hillary Wynn once again, mentored by Dr. May Thomas once again, and she'll be speaking to you on food market opinions of Loyola University New Orleans students, a comparative study.
Alright, thank you Dr. Bucola for that introduction. My name is Hillary Wynn. You guys remember me from the first talk, I hope, but if you don't, I am a senior. I am majoring in environmental sciences with a concentration in biological sciences, and I also am a major in theater arts as well. So for my study, I studied the food market opinions of Loyola University students, and this was a comparative study. So some quick background on how I got to this point that I am at right now. During my time here at Loyola, I've been able to learn more about myself and learn that I have a passion for food access and food justice specifically. I first got into this by taking the Jan term course that was taught in 2020 by Dr. May Thomas, Dr. Phil Buccolo, and Professor Marianne Gaffone, who heads up the environmental law school over at the law campus. Other than that, I just talked. I am also an environmental justice scholar, and my work is more geared towards food access in the greater New Orleans area as well. And I also help to head up the community gardens that is located right outside of the Monroe Library and Dana Center that was also started in 2020. So with that in mind, I was trying to figure out what to do for my senior capstone, what research to do. I was reading, finding article after article, didn't know what to do. I landed upon this article, eliciting university student attitudes towards farmers markets, the Hungarian case. This is a study conducted in 2022 at Corvinus University of Budapest in Hungary by a great team of researchers. So I read this paper. I was absolutely astounded by the work that they were able to do. They were able to study the undergraduate student body and really understand shopping habits of new incoming undergraduate students, this new generation, a new set of consumers, new set of shopping habits. It's things that we need to keep in mind when we're trying to grow the economy, grow food access to our greater community. So some quick background, that study was done in Hungary. We are not in Hungary, we are in the United States. So food access issues in the United States on this left box right here. As of 2020, 12.8% of Americans are food insecure to some extent. That is a post-COVID high. But pre-COVID, the high was in 2011 with a stat close to 14.6%. And in 2020, this is the most recent data that we have, 22.6% of university students in America were also found to be food insecure to some extent. Now, a lot of people assume that you have the privilege to go to university, it means you have the privilege to have food on your plate. That's not always the case. And so food insecurity can mean a multitude of things, whether it means not getting enough nutrients that you need for the day to be a healthy, proper, active human being, or if it means skipping a meal, if it means not eating at all, if it means not getting enough fresh and healthy produce in your diet. And so the growth of farmers markets. In 1994, mid-1990s, there were about 1,000 total farmers markets in America. Now, as recent as 2019, we have close to 9,000 farmers markets all across the country. And farmer markets, according to Brown and Miller, in a study from 2008, are a great way to bring fresh produce to local community members without having them have to break the budget or travel super far to get access to great fruit. Now, looking closer to our local community, New Orleans area. New Orleans, post-Hurricane Katrina, very often referred to as a food desert. A food desert is simply a location where there are not enough grocery stores close to all of the communities so that everyone has the accessibility they need to get their groceries for the day. We do have a lot of community initiatives to get rid of this, such as Iggy's covered here on campus. Community fridges located around the area. That's just fridges. They are stocked by community members very randomly, haphazardly, but you are able to grab food for free from those fridges as you please, as well as Crescent City Farmers Markets, one of our most popular, and deliverable groceries through local nonprofits to your door. With all of that in mind, we also have to keep in mind the impoverished neighborhoods here in New Orleans that are historically impoverished, and they do not have access to all of these, programs. So if you see these maps here, these maps were done in 2023 by a Loyola grad who recently graduated from the Loyola Law School. These maps were used made using the 2022 federal census data, and these are historically impoverished neighborhoods here in the New Orleans area. So first, on the top left right here, we have Central City, and then we have Holly Grove and Gert Town, and then on the other side, we have the Upper and Lower Ninth Ward, as well as New Orleans East. So if you're able to see on the side right here on the legend, these food retail stores, a lot of these neighborhoods, you'll see a lot of yellow dots up here, but not so many blue squares right down here. That's going to be the big box grocery stores that you see right here. And because of that, a lot of corner stores do not provide you fresh produce. They provide chips, sodas, snacks of the sort, things that cannot give you the nutrients that you need to be a human being and a healthy one at that. So with that in mind, we also have to keep in mind that for university students here in New Orleans, a lot of university students do not have cars. They cannot get to the grocery stores that they need. If they can get to the grocery stores, it's going to be quite a bit of a far drive, as New Orleans is considered to be a food desert. So, methodology. And so what I did to conduct this research, I first reached out to the researchers, the main researcher, Mauro, from that study that I previously mentioned. I reached out to him and I said, hey, I love the work that you're doing. Please, will you let me get access to the questionnaire that you used and expand on your study? He said, of course, that would be amazing. He sent me the questionnaire, and so then once I received it, I had to modify it a little bit, just for wording cases, for clarity's sake. In their questionnaire, they also asked about student income over a wide array of the student population. They used Hungarian currency, not US dollars. That wouldn't translate over too well, so I had to change just small things like that. After that, I was able to send it out to the student body this semester from February 5th to March 5th via Qualtrics, as well as the Loino email system. So they were all of our undergraduate student body were sent an email blast. They were able to log on for the month, complete this 10 to 15 minute long questionnaire, and then submit it as well. This is just a quick overview of what it might look like on your desktop or phone if you open it up with one of our questions, and then after that I was able to analyze that data. I did this through JUMP as well as Qualtrics and Microsoft Excel, and the main things that we ran were some chi-square tests. So, the results. We had a total of 141 responses. With that being said, only 107 of them could be analyzed due to them meeting the qualifications, such as they completed the questionnaire and didn't leave half of the questions blank. So, some big findings and some big takeaways. I would like to note here that we have so much data from this questionnaire. We have so much research that we're able to gather about the undergraduate student body here at Loyola, and there is no way that I would be able to share all of that information with you guys here today, sadly enough. So I've just chosen to take on and share with you guys the main takeaways. So for the first big takeaway, if there was a recurring farmers market on the university campus, would you shop there? And 97% of students said yes to this, with a p-value of 0.001, less than 0.001. And if you guys were to look at this graph right here, this shows you factors that contribute to their frequency at shopping at a farmer's market. The question stated, and this was a multi-select question, they could choose whatever factors, it was which factors cause you to shop at farmers markets as little as you do. We can see that the top two choices were distance as well as high price with 74% and 56% of answers. Again, percentages will not add up because it was a multi-select question. And if you guys look over at these two tables right here, this first one right here is going to be motivational factors when food shopping in general. So this is going to be food shopping at any store, whether that's Walmart, Rouse's, Winn-Dixie's, a corner store, anything of that, and what shopping habits look like. So what are students looking for when they're shopping, right? I have highlighted in blue, which I hope you guys can see that pretty well, quality as well as healthiness as well as external appearance of product. They were able to rate these factors on a scale of 1 to 5, 1 being not at all important and 5 being extremely important. So those were the 3 highest factors that students look for when shopping in general. However, those factors seem to change when they're shopping specifically at a farmer's market. So when they're shopping specifically at a farmer's market, they still look for quality and freshness of the product, but they also care most about the distance to the farmer's market as well as supporting local farms and farmers. And I also have highlighted in green at the bottom, again, hope you guys can see, the price of the products came in fourth, which means that students would be willing to pay a little bit more of a premium if it meant that they were also able to support local farms and farmers. And I think it's very interesting to note that on the first chart right here, support of local producers is at a low of 3.22, whereas on that side it is at a high of 4.02 on average. So with that being said, knowing that 97% of the student body would shop at a recurring farmers market, and knowing that distance was one of the main factors that they don't shop at farmers markets more regularly at 74%, looking at this chart right here, we were able to run this is a contingency table, and we were able to see if they answered yes or maybe to that first question if they would shop at the recurring farmers market, and if they chose distance as one of the factors that they don't already. So distance makes up 74, in total 74%, or 74.47% of responses of yes or maybe chose that distance is one of the reasons that they don't already shop more often at a farmer's market. And so then lastly, I have figure 3 right here. This is just interesting takeaway that I saw. Students answered that to these questions on a scale of, again, strongly disagree to strongly agree. I only chose to show the somewhat agree and strongly agree responses because it would have gotten too busy otherwise. But students say that with a student discount, they would shop at a farmer's market more, with 68% saying strongly agree and 24% saying somewhat agree that they would buy at a farmer's market more if there was also live music there. So 16% strongly agree and 31% somewhat agree. And then higher social media engagement with 41% or 42% strongly agreeing and 34% somewhat agreeing. So to conclude, my first hypothesis was that students would be open to the idea of a recurring on-campus farmers market. This is absolutely supportive. Again, with the previous data that I showed you guys. And secondly, my second hypothesis was that students would care most about factors such as low cost, convenient location, and having good quality products when shopping specifically at a farmer's market. I would have to reject this hypothesis because it is only partially supported. The first 2 factors of distance, of low cost, or of convenient location and good quality products are absolutely supported as shown in table 2 earlier on. But the low cost, the pricing of products comes in at 4th place, not 3rd. So discussion. Hopefully this will now give Loyola the tools it needs to develop a successful farmers market here on campus. And you have to remember that farmers markets do help to combat food insecurity. And a lot of you guys might be already thinking, don't we have a farmer's market already? Yes, we do. It's with Sodexo. People were able to choose this option to say that this is why I don't shop at a farmer's market more recently. A lot of students echoed this view when they typed in their response. Quote, the products at campus farmers markets are usually just Sodexo products I can find in the Orleans room sold for a much more expensive price. So something to keep in mind. So some recommendations for the future, hopefully setting up an actual farmer's market with actual food vendors in the Peace Quad or somewhere near the data center in a central location. Future studies, definitely, I didn't have the ability to look into this, but looking into food insecurity and its adverse health effects, it's something I'm extremely interested in. If you guys are interested in it, please think about taking it on as research as well. Reference rules. I would like to thank Dr. M.A. Thomas, Mark Copeland for helping me with the gardens over the years, as well as Princeton Emily.
We've got about 30 seconds for one question. Otherwise, you have to meet Hillary during our first break. Any question?
I know it's not like Loyola specifically, but I know Tulane does like a once a month farmers market. Did you do anything with that? I don't know if this is a Sodexo one. Like what you
I'm not sure for Tulane's campus at all. My study was mainly focused on Loyola.
Okay, thank you so much, Hillary.
Thank you, Hillary. All right, we're going to keep it rolling. And our next talk is Annie Sucombe, and she was mentored by Professor Mark Tobler of the Greenhouse and then some. And she's going to be speaking on interactive effects of solar UV and herbivory on flavonoid levels in okra.
Alright, so let's get right into it. So flavonoids are phenolic compounds found in plants that have many functions such as selective UV filters, antifungal, antipathogen, and anti-herbivory properties. For humans, flavonoids also have health benefits, such as the leafy greens that you eat, they have flavonoids in them. But plants utilize flavonoids for growth and protection. Flavonoids are found in all parts of plants. However, in this study, I focused on the flavonoids in okra leaves and their roles in protection against solar UV radiation and herbivory. Since light intensity and composition change throughout the day, plants naturally respond differently, such as at pre-dawn and midday. Pre-dawn is the period before sunrise, which is when plants get minimal to no exposure. Midday is when the sun is at its peak and plants are getting the highest UV exposure. Studies have shown that most plants exposed to UV radiation have higher levels of flavonoids. These flavonoids act as sunscreen, where they absorb detrimental UV light before it reaches the photosynthetic tissues in the leaves. In this figure to the left, the elephant ear species circle at the top has basically no change in flavonoids between the pre-dawn and midday, whereas okra, circled at the bottom, has the largest of the 37 species that the Barnes lab has tested. The figure on the right is an example of the diurnal cycling of flavonoids in okra that are exposed to UV during the day, shown on the upper line, and protected from UV during the day is shown on the bottom line. This is showing how UV triggers flavonoid response in the plants. So that leads to the question being asked in the study, does caterpillar herbivory increase flavonoid levels in leaves not exposed to UV? This past summer, from mid-June to early July, I planted 88 okra seeds that were germinated under shade in the Asby greenhouse to prevent pre-exposure to UV. Around the 3-week stage, 32 of those plants were chosen on bait size and were randomly placed under UV treatments. On the rooftop deck, the 2 treatments were made with plastic films that were placed over frames. One that allowed all visible light and UV, as shown on the right, and represented as plus UV. And the other blocked out UV, but allowed for visible light, as shown on the left, represented as minus UV. Plants were then grown outside and were watered and fertilized as needed until the plants had 3 to 4 fully expanded leaves. While the plants were growing, we ordered eggs of the Spodoptera frugiperta, aka the fall armyworm. They're a major crop pest around the world and a generalist, meaning they feed on many plant species. We chose this caterpillar over others because they're generally not picky eaters, and research has shown they readily feed on okra, so they're appropriate for this experiment. The fall armyworms were then taken out of their artificial diet and placed into Petri dishes with the surplus of okra grown from inside the greenhouse, which had low flavonoids due to not being exposed to UV. Then the caterpillars were put in an incubator that was set to mimic the temperature and light cycle that they would be exposed to outside on the rooftop deck. We did this to get the caterpillars accustomed to feeding on okra leaves and to the temperature outside, so there isn't a shock that changes their behavior. This helps us control their feeding and allows them to continue to feed on the okra, so when placed onto the treatments, they're not biased to the high or low flavonoid levels. The caterpillars were checked on 3 times a day to see if they had enough fresh okra to eat, and so I could clean out their frass. 30 caterpillars were reared for approximately 1 week until they were at their 3rd instar. We utilized 16 out of the 30 and eliminated ones that were not feeding well on the okra. Then we haphazardly picked the remaining ones to put onto the okra treatments. After all that preparation, we were finally ready to start. We started taking baseline measurements for 2 days, and we used these 2 instruments to record the data. So the pyrometer on the left was utilized for taking stomatal conductance as one way to measure the health of the photosynthetic system in the plants. And we used the dual X on the right to record the flavonoid levels. 2 leaves were measured on each plant. So we have the target leaf and the adjacent leaf on the same plant. The target leaf on the left is where we put the fall armyworms, and we looked at single leaf response in there. When placing the herbivores, I utilized mesh bags to keep the caterpillars on the leaves without damaging the stems and to allow airflow. In the adjacent leaf on the right, no herbivory was added to see if there was a widespread response throughout the plant. We added the fall armyworm caterpillars to the target leaves to feed on for approximately 2 days. We didn't take readings during those 2 days as to not disturb them. After that, we took the caterpillars off and continued taking readings on the same 2 plant leaves for 3 more days with the instruments. At the very end of the experiment, we took some leaf samples to measure the overall pigments in the leaves. All right, so this is other data collected that was caterpillar sizes, amount of frass produced, and the leaves before and after herbivory. This data will not be presented today because it's been more challenging than anticipated to analyze, but this is a visual representation of one of the before and after pictures of a leaf from a UV exposed plant. All right, before I get to the results of this study, here's a graph shown earlier of what's expected of the diurnal flavonoid response to herbivory. First, let me orient you to the graph because the graphs after this will be similar. On the x-axis, we have the days and sampling shown with the pre-dawn and midday. And on the x-axis, we have the flavonoid index. The dotted line is where we had the herbivory event. The upper lines represent plants exposed to UV and show a strong diurnal cycle of flavonoids with low levels at pre-dawn and high response at midday. After the herbivory event, it is expected that the flavonoids are maintained at a constant higher level. The bottom line represents plants not exposed to UV. This shows lower values overall and for less change in the diurnal cycle of flavonoids. After the herbivory event, it is expected that the flavonoids increase and maintain a constant high level. These are what is expected. Now let me show you the actual results of what we got. All right, so this graph shows the flavonoid levels of the target leaves. On the x-axis, the 0.1s indicate pre-dawn readings and the 0.2s indicate midday readings. On the left is the baseline levels before herbivory and the diurnal cycle that is expected. The middle is when the caterpillars were eating and readings weren't taken during that point. On the right is when we had the caterpillars removed. So the gray line represents plants exposed to UV but not herbivory, and they showed a continued diurnal response as expected. The yellow line represents plants exposed to UV with herbivory, had lower flavonoid levels that were opposite of the expected. These were significantly different from each other. The blue line represents plants not exposed to UV and without herbivory, and it showed the continued subtle diurnal response as expected. And then lastly, the orange line represents plants not exposed to UV and with herbivory, and it were expected to rise, which we didn't see. The minus UV was not significantly different. So this is a graph on the adjacent leaf. The adjacent leaf was looked at to see if there was a widespread response throughout the plant. Also note that the plus herbivory in these did not actually have caterpillars feeding on them. We found no change after feeding in the flavonoid levels in any of the treatments. Therefore, there is no systemic change in flavonoid response when the target leaf is fed upon. So we also looked at the stomatal conductance, which is the measure of the performance of the photosynthetic system. There was no significant difference in the target leaf or the adjacent leaf between any of the treatments. So this is the pigment data that was collected by gathering leaf samples to measure the overall pigments in both the target and adjacent leaves. These pigments are extracted and processed in the spectrophotometer at 330 nanometers, which is the range of 250 and 550 that flavonoid pigments absorb light and wavelengths. With the leaf pigments, it's a similar story. With the other one, there was no significant difference in any of the treatments. So in conclusion, plants exposed to UV had higher flavonoid responses, as expected with previous research. The target leaves exposed to UV in herbivory had lower flavonoid responses than expected. Some studies of other plant species have shown increases in flavonoids in response to herbivory. These results indicate a negative flavonoid response to herbivory. This is the first time this has been examined in okra, suggesting a possible reallocation of resources to new growth. Since okra is an annual plant that lives and dies in the same growing season, it makes sense for the okra to possibly reallocate these resources to new growth because the plant has short-lived leaves, it grows fast, and the leaves that we were testing on became older over the 7-day experiment. And I would like to acknowledge the support I received from Dr. Barnes, Professor Tobler, the assistance I received from Nikki, and the funding that made all of this possible. Thank you.
I was just wondering what was the reasoning behind the time scale that the experiment was conducted over? Like how we had a couple days before caterpillars, a couple caterpillar days, a couple days after. Is there like, how quickly in previous research does the flavonoid response happen? Is that based on that?
It's not based on the time span. It's just from previous research. Like 2 summers ago, I worked on this project, but we did simulated herbivory, and we did 3 days of baseline. It just seemed like too much because it was just the basic up and down of it. And then the rest of it, like we didn't get enough of a response from the herbivory that we needed. So if this was redone for future studies or anything, you could honestly do different time points in days of sampling.
Thank you.
Any other questions? This is super interesting, and I was just curious, like, what was the most surprising thing about your results? And it seems like with all the different UV treatments and the variables at play, I was wondering if there was anything in particular that was shocking.
I would say the most shocking thing was that the flavonoids didn't increase with the herbivory, because in other studies we do see that like it increases with like other insects. So it could have just been that the okra was dying and the leaves were like, I'm going to give up on this leaf and just focus to new growth and actually fruiting.
One more. When you were looking, this is qualitative, meaning you just observed it, but did you see feeding patterns of caterpillars that were specific to any part of the leaf? And I'm more thinking about the veins, right? The vascular tissue versus, you know, around where those veins are.
They mostly went around the veins. but there were some that wasn't shown exactly. There were some that they like ate almost the entire leaf and the veins. So.
Cool, thanks. So this will be our last talk for the first session. We'll have a 15-minute break after we listen to Miranda Bucky talk about life in Slow Lane, status of introduced swamp fields in Louisiana, and her mentor is Dr. Frank Jordan. Thank you, Miranda.
Good afternoon, everyone. As with Dr. Bigelow has mentioned, my name is Frank Buckeye. I am a senior marine biology student in Dr. Jordan's lab, and I'm going to talk to you about the status of introduced swamp fields in Louisiana. Now, to begin, I want to go over the difference between an invasive and an introduced species. Both an invasive and an introduced species are non-native to an area, and they were introduced as a result of deliberate or accidental human activities. The big thing to notice here is that an invasive species is inherently harmful to an area, whereas an introduced species is not. An introduced species can, over time, become harmful, and that makes it invasive. So let's talk about the star of our presentation, the cuchilla. It is a fish in the family Cyprinidae. Its common name here in Louisiana is the Asian swamp eel, where its scientific name is Amphiphilus cuchilla. These guys are native to Southeast Asia, so Nepal, India, and Bangladesh being some of the most prominent. They are fossorial, meaning they burrow. They're nocturnal creatures, opportunistic predators, and they are obligate air breathers, meaning that they have the ability to breathe atmospheric air and leave their habitats. They breathe via the pouches below the pharynx, as you can see, here it is, parts B and C of the photo on the screen right now. They also occupy aquatic vegetation in their habitats where they're found. We first discovered cuchilla in Bayou St. John in 2019, but it's important to note that an established population was already present in Bayou St. John before we initially discovered them. So why should you care about cuchilla at all? Well, these little guys have a high potential to become invasive for various amounts of reasons. One, they can tolerate some pretty harsh environments, and they can also tolerate some pretty rapid changes within those environments. One of the most recorded being salinity. They can tolerate various levels of salinity even in their young of year stage, although their adult stages. They have the ability to move from habitat to habitat because of their obligate air breathing. So if the habitat becomes too harsh for even them to handle, they can just slither their way onto a new home and spread pretty rapidly. They have an opportunistic diet, so they're eating everything from small inverts to different kinds of fish, meaning they're going to have a direct impact with the native predators of a certain area and native prey species. The biggest thing to mention here, though, is the fact that we're finding them in Bayou St. John, because Bayou St. John is hydrologically connected to Lake Pontchartrain and subsequently the Mississippi River Basin, which drains about 41% of our country's water. So if these guys start to spread, they're going to have access to most of the continents of the U.S., which is a major problem. Right here you see the standardized invasion curve for invasive species. As you can see, as a species remains in an area for a longer amount of time, it becomes almost impossible for you to eradicate a species entirely from an area, and it becomes more costly to do so. So the best thing to look for is if your species is at the bottom of this invasion curve in the eradication phase, because you have a better chance of actually getting rid of them in the area that they're located in. Higher up they are near the carrying capacity side of this invasion curve, you're no longer able to get rid of them. You have to direct funds towards long-term management. So what were our overall goals over the past 5 years of us sampling? We want to determine the distribution and the abundance of these species in Bayou St. John and figure out if they have moved to Lake Pontchartrain. We need to figure out where those cuchilla are on the aforementioned invasion curve that I just showed you. We want to identify the effects that they're having on any native species in Bayou St. John, and then use that data to inform proper authorities, being the Louisiana Department of Wildlife and Fisheries, on proper management in the future. So right here, we have a map of all of the sampling sites along Bayou St. John we were at over the past 5 years, along with our 2 sites at Lake Pontchartrain. Remember this box? It's very important. I'm going to come back to it later. The equipment we used over the past 5 years of sampling is relatively low tech, but very high in extensive labor. We used a YSI chromosolometer to record aquatic abiotic factors at each of our sites, and an aluminum flow trap and a barsane in order to collect samples of cuchilla and nectar. Sampling included first recording abiotic factors being dissolved oxygen, salinity, and conductivity, as we separately sampled that. And then afterwards, using the throat trap to collect water depth, canopy height, and plant species percent cover for the littoral zone of every site we were at. We then seine for quantitative data using the bar seine to collect chia and nectin samples, and then afterwards an additional 15 minutes of qualitative sampling using dip netting across the entire littoral zone of each site in order to collect any extra chia that we were getting with the throat trap. All of our collected samples were euthanized in MS-222 and then later preserved in 10% formalin. When it comes to processing and sampling, nectin samples at each site were classified by species, measured, and then recorded, and then later preserved in 50% ISO for later reference. And our data was recorded in Excel and then transferred to GeoPro 17 so I could make some nice pretty graphs for you and to just give an overall analysis of what we collected. Right here, we have the individual chia that we sampled. They were frozen for future DNA sampling, and we kept a single adult chia that we affectionately named Snoopy. This is him right here. For approximately 2 months for monitoring. We wanted to see if we can collect some video about showing him breathing and showing him feeding. We didn't get that, but he's still cute, so I wanted to put him in here. So, what did we find? Well, we saw that with our abiotic factors, we were finding temporal and spatial differences across all the sites over the past 5 years. I apologize for the colors of this graph. It's very hard to find 5 different colors for all of these bars, so I've tried my best here. But the most consistent abiotic factor that we saw was temperature with relatively stable levels of the entirety of the last 5 years. We saw variations in solidity and conductivity, but none were statistically significant enough to be statistically significant. And it is important to mention that all these abiotic factors are relatively normal to see in natural environments, and these trends aren't really out of the ordinary. We're finding also spatial and temporal differences in the total abundance and fish abundance that we were capturing in our nectin samples, along with our species richness. There, again, you do see variations in a couple of years, like in 2019, there's spikes in the total abundance, and then 2023, my year, pretty low numbers, but again, none of these proved to be statistically significant enough, but it is something you can see on this graph, so there's a trend there. If the total abundance and fish abundance graphs look the same, it's because we were collecting a lot of fish. So that's why they look pretty similar. Now on to plant biomass. We wanted to see how plant biomass in the littorals and of all of our sites had changed over the past 5 years. And one noticeable thing is the massive decline from 2020 to 2021. That is in part due to volunteer efforts in that year to eradicate invasive water hyacinth all around Bayou St. John. We do see a slight increase in plant biomass ever since 2021, but it's nothing like we're seeing in our first year of sampling, which is very important because, as you see in this graph, there is a positive correlation between the plant biomass and the species richness that we're seeing at all of our sites. So it's just a significant positive correlation. So the more plant biomass you have, the wider variety of species diversity you're going to have at each site. Now we're getting on to the good stuff. So this is graphs that show the distribution of cuchilla along Bayou St. John that we've seen and the overall abundance. This graph right here and the bracket here shows that the cuchilla are relatively bracketed in between sites 5 through 8, just like that little box I showed you on the site map. We did not see cuchilla outside this bracket over the 5 years of our sampling, meaning that we don't see any cuchilla in Lake Pontchartrain as noticed by the fact that we have absolutely no cuchilla in sites 14 to 15, which were our sites over at Lake Pontchartrain. This graph over here shows overall abundance by cuchilla per meter squared. This line right here is our overall mean cuchilla for the past 5 years, which turned out to be 0.0381 cuchilla per meter squared. And a rough estimate using that number gives us about 1,000 cuchilla, individual cuchilla currently occupying Bayou St. John. That's our rough estimate on the entirety of the population of cuchilla in Bayou St. John. One thing that's really important to note is that you can see differences in the abundance of cuchilla in both our abundance graph here and our distribution graph here. Similar trend to biomass after 2020, there was a decline in the population of cuchilla that we were finding. This is most likely in part due to the eradication of water hyacinth, as the cuchilla do use this plant and similar plants like it for their entire life cycle. Possibly not the only reason why we're seeing a drop in abundance, but it is significant for us to mention here. One of our big questions was, are Cuchilla affecting native taxa? And from what we find, there are weak but still slightly significant declines in certain taxa, native taxa owned by us. John, we chose the mosquito fish, the least killed fish, the silk and molly, the grass shrimp, and the crawfish. We chose these species to show for you today because other studies done in the Florida Everglades with their own invasive populations of different Asian swamp eels have shown these species in particular have declined rapidly due to the invasive swamp eels in those sites. We wanted to compare our results with theirs, and we're finding a similar trend, as you can see here, between the presence of Cuchilla and the decreased abundance of these species at each site. There are variations, as you can see over here with the skillfish, weirdly enough, or sorry, the mosquito fish, weirdly enough. There in 2019 there were more fish where the Cuchilla were present versus where they were not present, but again, you can still see a similar trend of a decline in abundance over time. So what were our big takeaways? Well, one, we've determined that the Cuchilla are still in the eradication phase of the invasion curve. They have a reproducing population, and that has been established, but abundance and distribution has not changed as much over the past few years in modern. And we've also determined that there is a concerning downward trend in abundance of several native taxa, as we've just seen previously. Again, we are right here in the eradication zone of the invasion curve. This is prime time to take action against invasive species. The earlier you catch it, the easier it is to manage it better. So if we're going to do something about this species, now is prime time. Future research. I would say an updated sampling method is in order. Our current sampling method, while effective for an animal of this size, still doesn't, it sometimes isn't as effective as we would like it to be. As I mentioned, the Cuchilla are a burrowing species, and as well as our throat trap works, we are not able to get our bar seine deep enough to actually penetrate any of the burrows that the species may be hiding in during the day. So it's possible that we're finding less Cuchilla because we're reporting less Cuchilla abundant in Valle St. John, simply because we're not finding enough with our current sampling methods. It's also pretty labor intensive, so if we have to find a new sampling method that we can use, which eDNA could be a more efficient sampling method, as proposed last year by my predecessor, Olivia Guerra. Hi, I know you're watching. That uses leftover cellular DNA that's in the water, or for us it would be in the water, to then look at and figure out overall abundance in a certain area. That's still under development currently in the Jordan lab, again, with Olivia Guerra. So acknowledgements, I would like to thank my mentor, Dr. Frank Jordan, for his groovy mentoring over the past couple of years. My predecessors, Dalia Martinez, Toy Rodriguez, Susan Thomas, and Olivia Guerra, who have been doing this research over the past 5 years. Y'all are amazing, and I look up to all of you. The sampling squad, Susan Thomas again, Mojo Williams, and Jamie Kinney, you guys really helped me over the summer, so I really appreciate you all. My friends and family have kept me sane, because this is a lot of data and a lot of fish that we had to sample. I want to thank Loyola University, and then I also want to thank Dr. Jakiernan and Dr. Jean Jakiernan Undergraduate Research Grant. Thank you very much. Yes?
So have y'all done a tagging method to sort of track it so that you can kind of like eradicate them at a certain point?
These Cuchilla are very, very slippery. Are you talking about tracking methods? Is that what you said?
The one where you
We're actually like tag the specimen. Cuchilla are very, very slippery species, and they're very secretive. So honestly, it's hard to find them to begin with, and it's even harder to grasp them. We were at Site 70, and we tried finding this one massive Cuchilla, and we couldn't even have a brand on it. So it's hard to actually like pinpoint where they're going to be, and then also tag them. I don't know if it's even possible. It could be on future research, but absolutely good. I'm not sure. We haven't done that.
What steps would have to be taken for the future eradication of the Cuchilla? Like, what would actually have to be done in order for this to go underway?
Well, I think stricter management on, we saw that with the eradication of the water hyacinth, there was at least a correlation to the decline of Cuchilla. So more stricter management on the invasive water species in Bayou St. John could prove useful in keeping the species contained. I'm not entirely sure the different kinds of chemical and or like physical management programs that are replacing Bio-St. John for this species. I don't think there really are. This is more of a hands-off approach for this species in general. But at least from what we're seeing, I think if we were to take care of the water hyacinth, we would be subsequently taking care of the Fuchsia in some way.
All right, it's time for a quick break, so y'all are welcome to meet Brandon and ask more questions, because those were great. And great stuff. We'll start back again in 15 minutes.
I want to break
No, but you showed it on the ground. Okay, I feel like you did a great job. You improved on the ground as well.
Hello, Joe. Hey. What's up? You little Your site is it the same vegetation as my St. John's? Look all the way down the shore. Is he sampling down by the Wrigley's and like you're shipping into the pass where salt water comes in? Yeah, Seabrook. Yeah, I got a site there too. Cool. Okay. That's good. Yeah. Thank you, that was awesome.
That's so interesting, and I'm just curious, like, in terms
So,
I'm doing this.
And then, I don't know quite your, I know, but, what's your walk rate?
Yeah.
Taken away. Not almost, so, just we didn't test that. We should. An overall, like, study on the overall changes after that. But honestly, that's good. See, I'm in Dr. People's lab right now. He left at work, took down predators and preys, that's his I had notes, and then the notes didn't come up on the screen. So I hope I did not tell. Very natural. Excellent. Very happy. What's up, Rose? You're supposed to be too. What's going on?
They're like,
First, the
Undergraduate.
And they pulled out like so
That $1 million home.
yes. Well, that was pretty cool about the main sense of the bar high. You know, because I kept thinking, y'all been looking at this in 5 years. Why? I mean, I understand, you know, where they oh, yeah. Now, I want to see. Yes.
Okay, they don't say anything. We're better. We're better. Oh, yeah?
Maybe not like so.
So I'm going to be introducing them this time. Just a quick reminder, we do have snacks in the back. Help yourselves. There's an entrance in the back if you don't want to come in through the front. Easy way to get in and out. And the other thing is that we are live streaming this. You can tell your friends if they want to watch it. It's you just search Loyola University Environment Program, and you will see our URS live streaming right now. And so any of the speakers in the next group, if you weren't here earlier when I mentioned this, you can either have a handheld microphone or a lavalier, so just tell me when you come up. And then also, we've got a slide advancer and a laser pointer, and then also stand about right here because that's where the people who are on YouTube watching can see you and the presentation. Okay, so just a couple of logistical things. All right, so we're going to go ahead and get started with Tyler Bueller, who has worked with Dr. Bucalo, and his talk is the monthly assessment of nitrogenous compounds in Audubon Park Lagoon, New Orleans, Louisiana.
All right, since we're going to be looking at nitrogenous compounds, I want to go over the importance of nitrogen and the specific compounds that we looked at. So nitrogen is integral to life, a component of ATP, the energy molecule, nucleic acids, amino acids, and proteins, as well as chlorophyll A, which is responsible for photosynthesis. And this makes it one of the most limiting nutrients in aquatic systems, driving bacterial and algal abundances because of its importance to metabolism, cellular respiration, and photosynthesis. And nitrogen is cycled throughout both terrestrial and aquatic environments in the forms of ammonia, ammonium, nitrite, and nitrate. And we specifically looked at the nitrification process, which is the oxidation of ammonia into nitrate, which is the primary uptakeable form of nitrogen, so it's very important to these phytoplankton. So nitrification begins with ammonia, and even though nitrogen in the form of N2 is 80% of our atmosphere, it has to be either biologically or industrially fixed into ammonia. So here we have nitrogen being fixed by microorganisms into ammonia, or through the decomposition of dead biomass, forming ammonia and ammonium, and this depends on pH, or through the runoff from fertilizers contains ammonia. And I'm going to include some ranges for you that you can use as reference for later on. So when we talk about our results. So ranges for ammonia include around 1 to 2 milligrams per liter for pond water, or 0.52 milligrams per liter for the center of a eutrophic lake. And in the next step of the nitrification process, ammonia is then oxidized into nitrite by chemolithotrophic bacteria. And the ranges for nitrite for Louisiana freshwater, which is also including the Mississippi River, which is a heavily nutrient-rich environment, ranges from less than 0.1 to around 1 milligrams per liter. And then continuing on the nitrification process, nitrite is further oxidized into nitrate by both chemolithotropic bacteria and cyanobacteria. So nitrate is often expected to be partaken immediately because of its importance and how limiting it is for algae, because it is the primarily uptakeable form of nitrogen. So nitrogen, not only through nitrification, also entered the system through fertilizers, through ammonium nitrate in those fertilizers. And ranges include less than 0.1 to 2.38 milligrams per liter. And nitrate is so necessary for algae because they cannot synthesize their own nitrogen, so they rely on the nitrification process to get this nitrate. So let's talk about Audubon Park Lagoon after we've been over the nutrients. So Audubon Park Lagoon is a freshwater, urban freshwater wetland with a very diverse ecosystem of insects, fish, reptiles, amphibians, and especially birds like the black-bellied whistling duck, because Audubon Park is home to a bird sanctuary and nesting ground during the migratory seasons. So Audubon Park officials employ around 5 aerators within the lagoon to drive the circulation of oxygen. And because the lagoon surrounds the Audubon golf course, they use fertilizers in that golf course, so we expect that to run off into the lagoon. So before we get to the question of hypothesis, I want to bring your attention to this graph right here, which is the dissolved oxygen in Audubon Park Lagoon over the course of several months and a few years. So hypoxia is when there's not enough oxygen for tissues or the system to maintain homeostasis. And when that happens varies between several different species, like for fish, hypoxia can happen around 4. But for the whole system, it happens around 2 or 3, so I'm being generous with this line. And every data point you see below the line is a hypoxic event within Audubon Park Lagoon. So this leads me to eutrophication, which is an excessive nutrient loading into an aquatic system. And when you're introducing this many limiting nutrients into a system, it can lead to a variety of things, from increased rates of decomposition, cellular reproduction, or photosynthesis. And Audubon Park Lagoon surrounds the golf course, so we expect it to be eutrophic. So we asked, how eutrophic is this system? So we hypothesized Audubon Park Lagoon to be a eutrophic system with concentrations of ammonia and nitrite being on the higher end because of the excessive nutrient load, but lower concentrations of nitrate because it is so valuable and so limiting in this system. So we expect that to be around 0. So it's being immediately taken around, not around 0, but expecting it to be very low because it's being immediately taken up by autotrophs. So here's how we tested this. So we had 3 replicate sites at Audubon Park Lagoon. We had the gazebo, the bridge, and Bird Island. And whole water was sampled monthly in around 1-liter containers like this one right here. And the samples were then transported back to the lab to be analyzed. And to analyze it, we used colorimetric analysis using this Hawk DR900 colorimeter that included corresponding powder pillows for each nutrient, like these you see here. And each powder pillow had a corresponding reaction time and the reagents necessary to conduct this analysis. So once the reaction was completed, the Hawk DR900 was blanked and concentrations were then recorded. So I want to walk you through the results for each nutrient that we studied. So for ammonia, in August, it looked fairly normal for the concentrations that, for the ranges that we had originally. But because in late summer we experienced that drought, once we got a lot of rain, it severely diluted the lagoon, getting lower concentrations. However, for December, January, and February, we saw a substantial increase of ammonia past even the ranges that we had. And these months were significantly different than the other months that we observed. Nitrite concentrations were pretty good. They did not indicate eutrophic in the beginning. We still see kind of a trend with the drought and the rain later on. But again, we saw a major increase in December and January. December and January being the months that were significantly different than the other months that we observed. Nitrate was curious though. So although that you can see there's heavy variability, especially in October and November, there were no significant differences found between the months that we sampled. So all of these, there were no significant differences found, and we were wondering, why is this? So I'm going to summarize the trends of the results. Again, ammonia concentrations were relatively normal for a eutrophic freshwater environment until we saw that substantial increase in the winter months. Similar thing with nitrite. It's intermediate in the nitrification reaction, but the increase was considerable in winter, especially around the same time as ammonia increasing. But curiously, nitrate remained consistently high over the observed months, even though we expected it to be 0, because there are some systems that are heavily nutrient limited that read nitrate as 0. So we're asking, why is nothing uptaking this nitrate? So what does this mean? So the increase in ammonia and nitrite were attributed to the heavy influx of migratory birds, such as the black-bellied whistling ducks, releasing nitrogenous waste into the lagoon. So that's why we saw that spike in the winter. We had also looked at a variety of abiotic parameters, such as temperature and rainfall. However, we found no significant differences between the concentrations of nutrients and when we correlated them with abiotics. So we attribute this to both anthropogenic manipulations and the need for a bi-weekly sampling timeline. And finally, the curiously consistent nitrate concentrations were likely attributed to the use of algicide in the lagoon by Audubon Park officials to maintain aesthetics. So this prevented things from uptaking the algae, uptaking the nitrate. So why should we care about nitrogen? So during the study, our findings indicated that rather than the eutrophication happening from the fertilizers from Audubon Park Lagoon, eutrophication was caused by a heavy influx of migratory birds unloading nitrogenous waste into the lagoon. And the hypoxic events that I had mentioned earlier were attributed to higher rates of decomposition from dead phytoplankton as a result of the algicide and the subsequent high rates of cellular respiration. So ultimately, we aim to implement this methodology in Lake Pontchartrain Basin. And I also want to thank my research advisor and co-author, Dr. Phil Bugalo, for his outstanding commitment and guidance throughout my entire research. And I want to thank all of my fantastic research collaborators in the Bugalo Lab, Brad Corcoran, Zoe LaField, Isabella Ramos, Ray Reville, and Angelica Solana. And I want to thank the Malahi Fund and Loyola University New Orleans for supporting this project. And thank you all for listening. Any questions?
You're talking about the connection between the nutrient load and the birds, and I was just wondering if that was just kind of based on observations of, y'all noticed there were a lot of birds when you went out, or if y'all had any kind of data set from y'all or from somewhere else to correlate that with numerically?
So we had just gone out, and there were a lot of birds in the winter months. So you could definitely see it, especially near Bird Island, which was somewhere they sampled because it's a nesting ground for these birds. Significantly more black-bellied whistling ducks because they're reported as being part of Audubon's system. So we just note that observation.
I was just curious, like, upon discovering that they used that a significant amount of algicide that's preventing the nitrates, bird nitrates from being fixed, have you all, do you plan to reach out and communicate this to Audubon in any capacity, or what do you consider like next steps being in terms of this research?
Well, the next steps would definitely be talking to Audubon about this, but they are well aware that they use the algicide, and they have said before that it was for aesthetic purposes. So I'm unaware of how they would feel about this information. So, yes.
You didn't, I don't know if you really turned to it, but the DO trend, it looks like a pretty substantial trend. I mean, just eyeballing data.
Yeah.
Is that part of future study? I mean, it's probably related, I would say.
Yes, it is part of what we studied. We did we did collect a bunch of abiotic parameters: rainfall, temperature, DO, salinity, and we correlated that with nutrients. And because my part of the project specifically looked at the nitrogen cycle, we had found no evidence of correlation between nutrients and DO, but because of these hypoxic events, we had to include it because it is such a substantial part of the project.
We have time for one more question. All right. Thanks, Kyle. Staying on trend with the Bugalo Lab, we've got Zoe LaField, and her presentation is titled Assessment of Phytoplankton Community Abundance of Audubon Park Lagoon, New Orleans, Louisiana.
Alright, so I'm going to start with a little background about phytoplankton. Phytoplankton are microscopic photoautotrophs that inhabit aquatic ecosystems. They account for about
50% of global primary production. So about half of what you see on that globe is from phytoplankton. And photosynthesis is the conversion of inorganic carbon dioxide, water, and sunlight to glucose, an energy source, while oxygen is released into the surrounding environment. And phytoplankton are a bottom-up food source. They serve as the foundation of aquatic food webs, and their photosynthetic output provides energy as a bottom-up food source for subsequent trophic level organisms. Phytoplankton respond rapidly to fluctuations in water quality. With excessive eutrophication, meaning nutrient loading in the water, phytoplankton respond especially quickly, inducing high concentrations of cellular respiration, leading to harmful algal blooms. Harmful algal blooms are known to cause excessive toxins in the water or induce hypoxic events. As you may remember, in the summer of 2023, there was a major fish die-off in City Park Lagoon due to hypoxic conditions at the time. That's what this picture over here is showing. Phytoplankton encompass various taxonomic groups, many of which are based on accessory pigments. So all phytoplankton contain chlorophyll A, the light harvesting complex of photosynthesis. Their accessory pigments allow them to absorb light that is reflected in the chlorophyll A spectrum, accounting for visible color differences. And if you notice in all of these pictures, these are algal blooms. These are from eutrophic environments. So we have diatoms, which are golden brown algae. You can see the color of this bloom is a little more brown. We have our cyanobacteria, which are blue-green algae. This group is actually a bacteria. Their blooms are typically a little more blue-green in color. And then we have chlorophytes, which are green algae. Those are the predecessor of land plants, and those are a true green color. So we conducted our study in Undergraduate Park Lagoon. It spans about 0.2 square kilometers and is very shallow with an average depth of about 2.1 meters. The lagoon hosts a rich flora of birds, reptiles, amphibians, fish, and insects. Biodiversity among the fish population in the lagoon is especially high. And because the lagoon cradles Audubon Park Golf Course, that makes it susceptible to eutrophication via groundwater runoff. So the purpose of our study was aimed at understanding phytoplankton dynamics in Audubon Park Lagoon over the span of a year. We were also interested in correlating changing phytoplankton abundance to changes in abiotic factors such as dissolved oxygen, light, temperature, available nutrients, which all in turn affect phytoplankton community success. So if you look over here, you can see that hypoxia is defined as about a general hypoxic event is defined as about less than 3 milligrams per liter of dissolved oxygen in the water. That's when cellular respiration for most organisms ceases. If you look above that, you can see that fish have a little lower tolerance, and their hypoxic events for them start at about 4 milligrams per liter of dissolved oxygen in the water. And I'm going to draw your attention to this graph. So we have dissolved oxygen in milligrams per liter on our y-axis and year on our x. This is showing dissolved oxygen in in Audubon Park Lagoon over the span of 4 years. So you can see any data points that were below 4 meant that that was hypoxia for fish, and anything below 3 meant that that was a general hypoxic event in the lagoon. We use 3 replicate sites to collect aquatic samples once monthly. We use the gazebo, which is at the front of the park, the bridge connecting the golf course to the rest of the park, and Bird Island. And then we use these samples to identify phytoplankton groups and quantify group abundance as well. We collected samples in 2 different ways. We used plankton toes with 10 micrometer and 35 micrometer nets for identification. After we identified groups, we then used whole water samples that were collected using a weighted bucket to find group abundance. We used M3 fixative to preserve all aquatic samples in this lab. M3 fixative is a solution of 2% glitter aldehyde to iodine. And it's important to use a fixative so that the degradation of cells is prevented, and then you can get an accurate cell count as well as accurately identify what groups were in the samples. So we have our whole water samples in 1 liter Nalgene bottles, and then we have concentrated samples from plankton toes in glass containers. You can see that the sediment on the bottom of those glass containers is actually phytoplankton. So our plankton toes were used for identification. We looked at the plankton toes under a microscope at 400 magnification to become familiar with which groups were present at each location during each month before we moved on to our cell counts. And if you notice, even though these are concentrated samples, there's not very much phytoplankton present. These were some of the groups that we identified. So under our blue-green algae, our cyanobacteria, we saw Anabina and Microcystis. Under our chlorophytes, which are green algae, we saw Cladophora, Gliocystis, and Pandorina. And then our diatoms, which are golden brown algae, we saw Cyclotella and Vicula. These were not all of the groups that we saw, but the most common ones. Then, so how did we find our cell counts? We used a hemacytometer counting cell, which is traditionally used to count blood cells. We use this to find group abundance in terms of cells per milliliter of water. So first, the average number of cell counts was calculated by taking the number of cells counted in the centermost grid and dividing that by the number of red squares in that centermost grid. After doing that, we could find cell density. So we took our average cells and then multiplied that by the dilution factor, which was 1 in our lab, and then divided that by the volume of one of those red squares. Again, if you notice, there's not very many cells present. Typically, a researcher is counting thousands of cells in the centermost grid rather than tens of cells, which results in hundreds of thousands or even millions of cells per milliliter. In this example, there's 5 cells. That leads to a cellular abundance of 400 cells per milliliter, which is extremely low. On to our results. So we have phytoplankton abundance in cells per milliliter on our y-axis and month of sampling from 2023 to 2024 on our x-axis. Before we get into the graph, remember, typically cell counts in eutrophic conditions are in the hundreds of thousands. The maximum number on our graph is 7,000. So we have cyanobacteria in blue, which clearly dominated this ecosystem. We have our diatoms in brown. They showed up, but in very low abundance. And then we have our chlorophytes, which appeared sporadically. If you notice, there's an increase in October and November of cyanobacterial abundance. So let's investigate that a little closer. So again, we have our cyanobacterial abundance in cells per milliliter on our y-axis and month of sampling on our x. You can see that there's an increase in October and November. Although there was an increase, ANOVAs showed no effect due to month, and Tukey tests showed there was no statistical difference in abundance between months. So even though we correlated that increase in cyanobacterial abundance in October and November to an increase in dissolved oxygen. So if you look at that top graph, we have dissolved oxygen in milligrams per liter on our y-axis, and then again month of sampling on our x-axis. You can see that dissolved oxygen also increased in October and November. I said we correlated changing phytoplankton abundance to that abiotic factor. It was a very weak correlation. Our R-squared value was 0.3, which gives you about 30%. Even though that's very low, that was the strongest correlation that we found in our study. Cell counts under normal cell counts under similar conditions. In eutrophic environments, phytoplankton abundance is typically orders of magnitude higher, and you typically have algal blooms covering the surface of the water. So why is there so little algae in such a eutrophic environment? Well, park officials add algicide to the water, which actively induces algal deaths to prevent green filamentous blooms typically seen in the spring, as well as to prevent the growth of various pond skunks. This is extremely concerning because at some point, the lack of phytoplankton and thus dissolved oxygen in the water, despite the addition of numerous aerators, will affect beloved upper trophic level organisms such as fish, reptiles, and amphibians. So it's likely that we're going to see a major fish die-off similar to what we saw in City Park. And then this study was the precursor to a larger initiative where Dr. Bucolo's lab will be looking at correlating changing abiotic factors to phytoplankton dynamics in Lake Pontchartrain Basin. So be sure to stay tuned for those results in years coming. And then I would like to thank my research advisor, Dr. Bucolo, for his unwavering support through this endeavor. I'd also like to thank my team members, Isa Ramos, Tyler Bueller, Ray Reville, Brad Corcoran, Angelica Solana for their contributions to this project. And then finally, a special thanks to the Malahi Fund and Loyola University New Orleans for providing the necessary financial support to make the study possible. We do have 3 minutes for questions.
I have a question. So this is a dumb question, but what would be you went to talk to Audubon Institute, and they said, well, we like not having all this green algae on top. We're just going to put some more aerators out. Does that help? Does that not hurt? What's the end result? Is that the right reaction? How do they react?
There's been, let me go back to this graph and show you. I think that will help my answer. Let me get there. Give me 1 second. Okay, so you can see there's 5 aerators in the lagoon right now, and there's a downward trend. So in 2024, most of those data points were, there was hypoxia in the lagoon. So I guess the answer to that is not necessarily. The aerators aren't helping that much.
Do you think that there's a chance that they will actually stop using the algaecide, or just like?
No, absolutely not.
So are there any higher order plants in that environment? Because, you know, I've been an Aquarius for like 50 years, and algae is the bane of everybody who keeps aquariums. So one of the ways we keep algae under control, aside from restricting light, is restricting nutrients through competition. So are there like abundant submerged aquatic vegetation in this lake?
No, there is not.
Because that basically beats an algicide if you have competition for all of those nutrients. Water hyacinth is a great sponge for a lot of stuff, but it's obnoxious in how it grows. Okay.
Yes.
I'm sorry, what was the adjective you used to describe fishes?
They have a lower tolerance for solid oxygen.
I think it was beloved.
Oh, beloved, yes, they're our beloved higher order trophic.
Thank you.
I'm sorry, that's not a question. Anybody else? Okay, thanks, Sam. Okay, y'all, our next talk in this session is by Isabella Ramos, and she's going to be speaking about the phytoplankton primary production in Audubon Park Lagoon, New Orleans, Louisiana, in the same lab, Dr. Rubela's lab. And I want to just point out one more thing, if you're following along in our booklet. Next to her name is an asterisk, and next to my name is an asterisk, and a couple other faculty members and students. She is currently the president of Tri Beta, which is our biology honor society that Dr. Hauber, Professor Emeritus, so brilliantly oversaw and moderated for 30 years. Am I getting that right? And decided he'd pass it on this year. And so Dr. Kim Mix is heading that up now. So you'll notice there are future speakers today that also have that asterisk, either newly initiated or have been members already. And just what you initiated, about 20 people this year, including some of the faculty members. So we're real excited about this resurgence. And if you're interested in being a member of Tri Beta, talk to Dr. Mix. Awesome. So, Isabella.
Hi everyone. We're going to start with what is primary production. Primary productivity is the rate by which radiant energy is converted via photosynthesis to organic substances. It provides an energy source to any photosynthetic cells or organisms via sugar. It provides a food source for herbivorous primary consumers and then the cascade of consumers in the food web, which is right here. The end result for autotrophs of photosynthesis is glucose and oxygen, and primary production products are the drivers of the bottom-up food web. Because producers make and consume sugar for their own cellular respiration needs, the grazers get to profit off of this because there's always going to be extra sugar. Who are our primary producers? Primary producers are photosynthetic autotrophs, which include plants, eukaryotic algae, and prokaryotic cyanobacteria. All these producers count for 100% of primary production, but phytoplankton specifically accounts for about 50% of global primary production. What affects primary production? Light is the driving force behind the conversion of inorganic carbon to organic sugar, and so without light, there's no photosynthesis and no primary production will occur. Nutrient availability is a little bit more complicated to explain, but basically the most limiting nutrients in an aquatic environment are phosphorus and nitrogen, which also make up the essential molecules of life, which include ATP, amino acids, proteins, and phospholipid membranes. All of these and more are components in things like chloroplast, for example, which is where photosynthesis occurs through the major pigment of chlorophyll A. So if you look here and the molecule of chlorophyll A, you can see how there's 4 nitrogens. And so in order for chlorophyll A to even exist, you need nitrogen, and you need nitrogen to be available in the ecosystem. Audubon Park Lagoon was established in 1907. It's located on the southwest side of Audubon Park. It's a very rich upper trophic level ecosystem surrounded by Audubon Park as well as the golf course. We suspect the manicuring of these lawns has an effect on the primary production output, and we do have ecosystem health concerns. So over the years, Dr. Beeple has spent studying the lake. We can see here how the dissolved oxygen continues to drop. So in 2021, it's almost reaching 14, whereas 2024, we're almost reaching about 10. And these levels are approaching levels that are consistent with hypoxia, which is really concerning. So for the first time ever, phytoplankton was measured. Primary production of phytoplankton was measured in the Audubon Park Lagoon. Because we believe that there's a very threatened bottom trophic level component of this ecosystem, we really wanted to understand the energy allocation of this foundational trophic level. So our question is, what is the primary production output of phytoplankton in Audubon Park Lagoon, and how does it change over time? So we sampled in 3 sites. Here's a gazebo, the bridge, and Bird Island, where there is a bird sanctuary. This first picture here is of a bucket that I threw into the water. It's in the photic zone, so we were able to use the bucket on a rope and get about 2 liters of water. And then we used this light meter in the middle. It's called a PAR meter for photosynthetic active radiation, and we had it throughout the water column where we can measure the level of light. And then this last meter is a wise eye dissolved oxygen and temperature probe where we collected the temperature when we were out in the field. So once we brought all the water back to campus, we separated them into 8 replicates. 4 were transparent and 4 were opaque. The opaque ones are here, and they were wrapped with aluminum foil so that no light would be able to come through. Using that same wise eye meter that I just showed you, we took measurements of dissolved oxygen in each of the test tubes in milligrams per liter and as a percentage. Then they were all put inside an environmental incubator where the incubator mimicked the day's light and temperature for 4 to 5 hours. And then once those 4 to 5 hours were up, we took them all out and we retested them for their dissolved oxygen concentrations. So in order to find productivity, we had to convert oxygen to carbon with an established equation and quantified conversion factor, which is from Strickland 1979. We used these two equations here, and the units were milligrams of carbon per meter squared per hour, where consumption is R and fixation is NPP. C was a conversion factor of liters to meters cubed. H was the height of the water column, and P was the oxygen-carbon conversion factor of community net production. And R was the oxygen-carbon conversion factor of community respiration. However, our main goal was to quantify primary production of phytoplankton, so we had to focus on gross primary production, or the GPP. Net primary production, or NPP, is whatever sugar is left after respiration occurs. So if you're able to quantify both of these things, you can subtract them from each other and get the gross primary production, which is this equation here. And so these are our results. On the y-axis, you have gross primary production in milligrams of carbon per meter squared per hour. And on the x-axis, we have months sampled from 2023 to 2024. And as you can see, there's a lot of variability here, which in reality, the range is only from 0 to 10, which I would like to stress is horrifyingly low numbers, because most systems similar to this have numbers in the hundreds, and we didn't even reach 10. So when we did more analysis, we saw a statistical difference between June and July versus the rest of the months, and that could just be because it was summer, there was more light, it was hotter outside, but then there was a drought in New Orleans at the end of summer, and that's why you see the numbers plummet here in August and September. And in hindsight, we were worried about June and July, but we should have been more worried about February and September because they were under the line of 0, which means that net respiration actually occurred instead of net production. Here we have the surface light level, so it's surface PAR on the y-axis, and then the months of sampling again on the x-axis. And there is sufficient amount of light, so in terms of light availability, there really wasn't any limitations. In April and September here, you can see how they're a little bit lower, and that's probably just due to cloud coverage at the time. Phytoplankton can photosynthesize in levels up to 10, which we had way more than that every month, so there was no light limitations. And as Tyler previously stated in his talk, there really was no nutrient limitations either. So we ran some correlations, and we didn't really find anything substantial. This was our highest correlation of gross primary production and surface level light, and it was only 27%, which is pretty low. But it does reinforce my earlier statement that the more light there is, the more gross primary production there will be. Overall, we saw the lowest primary production numbers that most wetlands have recorded ever. We looked into a similar study that was done in a moderately productive estuary in Africa, and they had gross primary production averages of 125 milligrams of carbon per meter squared per hour, while our highest concentration of Audubon Park Lagoon was 9 milligrams of carbon per meter squared per hour in the month of June. So what does this all mean? The park has motivation to keep the lagoon aesthetically pleasing, so they've been deploying algicide continuously. And so our numbers actually make perfect sense, because why would there be any output if there's no algae at all? And once again, this is a precursor to a bigger study that will hopefully have way better numbers in Lake Pontchartrain Basin. And I would like to thank Dr. Vicolo for being a great mentor and believing in me, and Doug Castellano for being my partner throughout this whole entire process. And then I want to thank Zoe, Tyler, Ray, and Brad for their contributions to this project, and finally the Millay Fund and Loyola University New Orleans for providing the funding that made this study possible.
We have plenty of time for questions.
Do you think that this whole project was successful once you really defined out?
I think that we were successful just because this study is again a precursor to a larger study, so we were able to perfect kind of like our methodology and like what we're looking for. Yes?
would suggest that the park not deploy algicide anymore, but I really don't think they're going to do that. So, yes.
So this kind of question, I guess, would kind of apply for all of y'all who have been working on this project, but why those 3 sites in particular? Because I noticed they're all kind of on one side of the park. Is there any reason y'all didn't spread them out more throughout the lagoon?
I don't really think there's any particular reason, but the lagoon kind of, no matter where you are, we kind of took an average of all the sites because there really is no movement in the lagoon at all. So like, I don't think it really mattered where you would go. You kind of see the same numbers everywhere. Yes.
With the numbers that were significantly small in August and September, because of the drought that had happened, if the drought hadn't happened in the time period that it did, do you think that it would have been higher than July in August, or it would it start to come back down? Essentially, does it peak off in July, or?
I think it does kind of peak off in July because that's kind of like that end of summer. I think that the numbers would have been closer, but not greater than that. Yes?
So from moving this study to Lake Pontchartrain, where there's some brackishness and more like the water's rougher and all that stuff, would you expect the same kinds of algae and amounts of algae to be growing? Sort of what would be the differences in kind of how you calibrate your study compared to the Ottawa Department?
It's definitely a bigger study, and I think that there would be more algae just because there's no one kind of really maintaining Lake Pontchartrain. So I think that there would be like more room for discovery and like more room for growth throughout that project.
So what about the canals that empty into Lake Pontchartrain? Do you have any kind of plans to take measurements where the canals empty into Lake Pontchartrain? Or the Bayou St. John, for example?
There are plans, but I'm not 100% sure about that because that's not my part of the project anymore.
Anyone else? Okay, thank you. Okay, our next speaker is a great example of multidisciplinary work. And so Ray is working in 2 different labs with Dr. Bucalo and with Dr. Stevenson. And I'm sorry, Abigail Ray Reveal, give her full name, is going to be speaking about the methodology for separation and quantification of Lake Pontchartrain Basin algal communities via LCMS. Right? Okay.
to you about how we're going to be able to quantify phytoplankton biomass based on their algal pigments. So like you've been told, this is a chlorophyll, which is a green algae, Clostridium, a blue-green algae of cyanobacteria, which is Anabaena, and then a diatom, which is a golden brown algae of Cyclotella. All of these are great food sources for aquatic grazers, as you can see here. We have a rotifer eating some chlorophyll algae, and then they are also great for primary production, and they are responsible for about half of all global primary production. These are some local green algae that you can find within our Louisiana waterways, such as Lake Pontchartrain Basin, and our Clostridium is our green algae analyte of interest that I will talk to you later in this PowerPoint about. And then we have our blue-green algae, which is our cyanobacterial group. And these are also local algae that can be found within our waterways in southeast Louisiana. And our Anabaena is the analyte of interest for this group. And then we have our golden brown algae, as you can see here. And our analyte of interest for this one is our Cyclotella, and this is one of our future analytes that we will continue to study. So all of these phytoplankton are very important when monitoring Lake Pontchartrain Basin because of all of these crabs, shrimp, and redfish. So all of these upper-trophic organisms call Lake Pontchartrain Basin home. And when we have events such as the Bonnet-Carré Spillway opening and hurricanes, there is an influx of hot, nutrient-rich water. And these phytoplankton communities, such as cyanobacteria, are able to exploit those nutrients and have such things such as harmful algal blooms. As you can see here, this is a satellite image of a blue-green cyanobacterial algal bloom. And this is not an enhanced image. They're in just such abundance that you can see them from the satellite image. And these algal blooms here can eventually work their way out of the Lake Pontchartrain Basin and into the Mississippi Sound. And they can last for a very long time, and they can lead to fish kills and beach closures. So the purpose of this study, we are going to be able to eventually quantify the biomass of phytoplankton using their algal pigments as a proxy for that. But before we're able to do that, we have to do method development of an extraction technique, a separation technique, and then we have to be able to analyze the primary and accessory pigments within these phytoplankton, and then we're able to quantify them. Doing this we are doing this by using monocultures from the Carolina Institute, and then we are hoping to use this methodology on real-world samples. And then we have a long-term goal of setting up a monitoring project on Lake Pontchartrain Basin using LCMS technology. So, you keep hearing me, oh no, when we started this, we had to take some analytes to, what did I do?
I think you just turned it off. Press it again.
Okay, all right. So when we started this, we had to pick some analytes to study, and we chose a Clostridium, which is a green algae, an Anabaena, which is a blue-green algae, and then a future analyte that we were going to study is our Cyclotella, which is our golden brown algae. So all of these house what we call pigments, and that is what we are trying to measure in this study. And to get those pigments out of the phytoplanktonic cells, we have to do what is called a phytopigment extraction. In doing this, we take our culture from Carolina, we split it to make sure we don't use all of it so we can reproduce our data later on. And then we let those grow for about a week or two until they are in abundance, and then we filter them onto Whatman glass fiber filters. As you can see here, the little Anabaena have been filtered from their liquid. And then we take it and fold it up and we soak it in 2 milliliters of acetone. Over here, you can see that we then sonicate it for 30 to 60 seconds in an ice slurry to reduce heating. And then we pop those into our negative 20 degrees Celsius freezer overnight. The next morning, we take them out and we actually remove the filter and we centrifuge them down at 5,000 RPMs for 15 minutes. And then we take them out, we remove the liquid portion of that, put it into a glass syringe, and then we filter it through a PTFE filter, as you can see here, and then into our autosampler vial, which then goes into our LCMS autosampler tray.
You keep hearing me say LCMS, and that stands for liquid chromatography mass spectrometry. And right now we are in the LC portion of this instrument, as you can see in the red box. And this consists of our solvent cabinets, and then the auto sampler that's where our little sample vial is. And then we have our binary pump, which then pushes our solvents through our column compartment, and our column is what is doing the separation of these pigments. And then we have our diode array detector, which is what is allowing us to measure the visible spectrum of these pigments in nanometers. And this is just a more up-close version of the LC, which is high-performance liquid chromatography. And as you can see here, our sample is injected onto our column, and this is an actual picture of our C18 column. So as our analyte or sample is introduced to the column, it is passing through and then eluting onto our detector here. And then our detector is then putting that information into our data acquisition system, which is a computer and some software that allows us to analyze these results. So our detector is what is actually letting us do this, and it is a diode array detector, and it's that little box right there. But the optical system within this detector is what really is doing the work here. And I know this is a lot, but the main thing that I want you to take away from this is our deuterium lamp, which is letting the light source come through here and hit that grating. And that grating splits all of the light waves onto our binary gradient. No, our diode array, sorry. That grating is splitting, and then we get our diode array, and that is what allows us to measure the visible spectrum of all of these pigments. So this is what a UV spectrum of a chlorophyll A molecule would look like. As you can see here, and we all know chlorophyll is green, so it is reflecting the green spectrum, which is why you see the absorbance in the 400 nanometer range and in the 700 nanometer range. There are also things such as chlorophyll B, which we call accessory pigments, and that's what the chlorophyll B molecule looks like. And as you can see, the chlorophyll B molecule is absorbing in a slightly different wavelength than the chlorophyll A, which allows for optimization of photosynthetic output. So now I'm going to get into this. So while chlorophyll B is an important accessory pigment, there are a plethora of them in many different colors, and each of them correspond to a different alkyl group. The main ones that I will be talking to you about today are chlorophyll B, which are housed in the Clostridium or green algae, zeaxanthin, which is in the blue-green algae or Anabaena, and then our fucoxanthin is a pigment that is in the diatoms that give them their golden brown color, but that is a future analyte also. And then this is my data. So this is a chromatographic table that is produced by our data acquisition software. And as you can see here, our column, as the sample goes through the column, it is being separated, and the chlorophyll B molecule is eluting at the end of this and passing onto our detector at a faster rate than our chlorophyll A molecule, and that's because there is less of it compared to the chlorophyll A. And then we take these peaks and extract them using our data acquisition software to give us something called a UV vis spectrum, which looks like this. And as you can see, the chlorophyll B molecule from that first peak, we extract it and we get this spectrum. And then we extract the second peak from that chromatograph and we get this chlorophyll A spectrum. And then the same concept applies for the monoculture of our Anabaena. And then, as you can see here, same concept applies. The carotenoids are coming out at a faster retention time than the chlorophyll A and our zeaxanthin because they are moving through our column at a faster rate and eluting off at a faster rate. We then use the data acquisition software to extract those peaks and get our UV vis spectrum of Anabaena monoculture. And this is our chlorophyll A spectrum of that, along with our zeaxanthin, which is our accessory pigment within the Anabaena monoculture. And then we have our carotenoids. So the only difference between these two carotenoids is that double bonded oxygen group. So using our UV vis spectrum alone, we're not able to differentiate between these two structures because their UV vis spectrum is the same orange line running from about 400 nanometers to about 500 nanometers. We're going to be using mass spectrometry, which is the MS portion of our LCMS system, to further differentiate these on a molecular level. So conclusions so far and our future work. So thus far, we have developed a methodology for the separation of the Anabina and the Clostridium monocultures. We will then use DHI standards to create a calibration curve, which is an external calibration method to be able to quantify these monocultures, and then hopefully we will be able to use this for other monocultures and then apply it directly to real-world samples in Lake Pontchartrain Basin. And we will also be using the LCMS in future studies. Thank you so much to Dr. Bucolo and the Bucolo Lab for everything that y'all have done. Thank you for everything and teaching me what phytoplankton are and that they are these beautiful organisms that allow us to have the ability, I guess, yeah. And then thank you to Dr. Stevenson and Dr. Duggar for everything on the organic and the instrumental side of this. I would also not have been able to do this without y'all. Thank you to Dr. Lori Earls for letting me use her lab and equipment whenever I needed it. And thank you to Nina Bertuznik for being my partner in crime and just helping me through all of this. And then thank you to the Loyola University Milwaukee Fund and the August Helmer Jr. Distinguished Professorship of Chemistry. Thank you so much for your time. And if you have any questions, I will do my best to answer them.
So is the goal of setting up your standards with your pigments to be able to then take samples and identify what algae are in various blooms in the water using pigments?
The DHI standards? So the DHI standards are from like a company that we know that it's only chlorophyll A. So we'll create a calibration curve, which is a concentration versus absorbance. So
Right, I understand that, but I guess my overall question is, why use pigments at all as opposed to something like DNA? Like, what is your what are you going to ultimately use? Like, how are you going to use this on your samples of like
the calibration curve gives us y equals mx plus b math, which we can then plug in absorbance from our unknown samples and then backtrack that to the concentration of these pigments. And then you can use something called chemtax, and you can plug those numbers into chemtax, which then backtracks to biomass.
So you're not interested in which actual species or whatever are in there?
I am not at the moment. That is for future work. We are just developing the methodology for the separation of these pigments on, this is like very ground level work.
Anybody else? Okay. Our final talk for this second session is about to begin. And I just wanted to remind all the speakers and their mentors that we're going to gather on the stage during the 2:30 break to take a photo, a group photo. So if you could be here, that would be great. We'll get that done, and then you can take your break. All right, so our next speaker is David Engelhardt. And David worked with Dr. Bucolo as his research sponsor, and with a Tulane professor, Dr. Olin Jackson Weaver. And bear with me, I'm an ecologist. His work is entitled Dimethyl Sulfide Prevention of Endothelial Glycocalyx Degradation in Rat Hemorrhage Lung Model. Take it away, Dave.
So it's going to be a little bit of a jump from the environmental science stuff, but what I'm basically showing is that a particular drug has clinical significance or could potentially possess clinical significance in improving trauma patient outcomes. I'll explain what the actual title means through the course of the presentation. Okay, I'm going to talk about trauma generally and very broadly. So trauma is the leading cause of death for individuals under the age of 45 in the U.S. And as a field of medicine, it's really understudied. So if you see like what the hot topics are, what's getting a lot of funding, a lot of grant funding, in big journals like Nature and Science, you see a lot of cancer or infectious disease, a lot of virology, but trauma is still leading cause of death under the age of 45, right? Okay, one aspect that leads to trauma with such high mortality rates is hemorrhagic shock. So shock is just a symptom or a point in your body which you don't have enough blood flow to effectively perfuse your organs, right? Now, resulting from hemorrhage, extreme bleeding, that's where the actual shock comes from, okay? Now, one particular disorder that occurs during hemorrhagic shock and occurs during trauma are different coagulopathies. So if you break down the word coagulopathy, coagul, which means coagulation or blood clotting, and pathy just means a disease or a problem. So a problem with clotting your blood effectively. So if you have a problem clotting your blood while you're bleeding out, hemorrhagic shock, that's not good, right? Okay, so a particular subset of coagulopathy deals with endotheliopathy, and this is where what our lab studies. So I'm breaking down this word again. Endotheliopathy is a problem with endothelial cells. Now, what endothelial cells are, they line the endothelial layer of all of the vasculature of your entire body. So all of your arteries and your vessels have an endothelial layer, which is just a one-cell layer which possesses a special matrix called the glycocalyx layer of the glycocalyx matrix, which is just a collection of glycoproteins, glycolipids, and it serves a protective role for preventing unwanted diffusion from any like ions or proteins that should be filtered out by your kidneys. We don't want those diffusing across the vascular wall of any of your arteries and veins, right? So that's why it serves as a protective layer. Now, during hemorrhage, during damage, the endothelial layer can get damaged, okay? And in the acute scenario, that leads to some pretty bad symptoms, such as autoheparinization. So what heparin is, your body produces heparin in certain scenarios. It's an anticoagulant, okay? So it prevents your blood from clotting. Now, if you're in the back of an ambulance and you've just been shot and you're bleeding out and you're in hemorrhagic shock, that's not good, right? You want to be able to clot your blood effectively, okay? So, damage to the endothelial cell just results from a shedding or degradation of this glycocalyx layer, all right? So you can see here a little graphic shows shedding of some of those glycoproteins, glycolipids from the endothelial membrane, okay? So that's measurable. We can measure the actual amount of glycocalyx shedding, the damage, all right? And two ways. I'm going to talk more about this in the methods section, but one way is just actually looking at the vessel intensity of glycocalyx, which we can do with under a microscope. I'll talk about that later. And the other way is actually looking at the concentration of a particular glycoprotein in the blood, right? So if you have shedding of your glycocalyx, of these little glycoproteins here, they're going to be away from the membrane and they're going to go into the plasma of your blood, all right? I'm going to talk about that in the actual analysis section. Okay, so what our lab does is we look for drugs or small molecules that could be used as drugs to prevent this glycocalyx shedding. So the shedding of the glycocalyx is bad. We want to prevent that so we can improve hemorrhagic shock patient outcomes, okay? One drug that I was involved in and I did trials on is dimethyl sulfoxide. It's a simple organic solvent, very, very common organic solvent, pharmaceutical solvent. And we actually were using it for different control trials in our lab, and we thought, hey, it might have some therapeutic effects, so we're going to try it out as its own drug. Okay? So that's the question. Can DMSO prevent this glycocalyx shedding, which we know is bad? All right, so we can't go around and cut a person open and bleed them and look at their glycocalyx, so we have to do it on an animal or a smaller animal. We're going to do it in a rat model. This is a very busy slide. I'm going to break down what this slide means in sections, but the most important thing is to get down to groups, okay? So if we're looking at whether DMSO can help or not, we have to first get a group that is hemorrhage. So that's what the HR stands for, the hemorrhage group. These rats are going to be hemorrhaged, they're going to be induced in a hemorrhagic shock, and they're not going to be resuscitated with DMSO. They're just going to be resuscitated with normal fluid. The HR DMSO group are injected with DMSO following hemorrhage. Okay, so we're going to be comparing those groups. Now we also have a sham group. Sham just stands for a sham trial group. All right, so these rats are going to undergo a small procedure that I'm going to talk about in a second. But what the important thing is, they're not hemorrhaged. Okay, so these rats theoretically should not have any damage. Okay, or any damage to their endothelium. So the method is, or the procedure is, we're going to anesthetize a rat. We're going to do a small surgery, which we insert some catheters into some certain veins or arteries. And I'm going to show some actual live video in a second of that procedure. And then they're going to be hemorrhaged until the point of hemorrhagic shock. So they're going to be blood pulled out of them to sort of like simulate as if you're in a car accident, you're bleeding out. And then they're going to be resuscitated with either fluid or, depending on the group, DMSO and fluid. Okay, so the next slides are kind of graphic. So this is a live demonstration or a live surgery of one of the aspects of the procedure, which is the dissection of the jugular vein. Okay, the jugular vein is where we're going to be infusing the fluid or the DMSO for the actual trials. Okay, so next is the femoral artery dissection. So we're doing a bilateral femoral artery dissection, and each femoral artery serves a purpose. One of the femoral arteries is where we're actually going to be pulling blood and inducing that hemorrhage. The other is actually hooked up to a pressure transducer where we're going to be measuring the rat's blood pressure and saying, yeah, okay, we have actually successfully induced hemorrhagic shock. All right, so those two things are very important. This is another busy slide. I'm going to break it down. So in the intro, I talked about how we could look at different analysis methods, two main methods for actually measuring glycocalyx damage, or the shedding. One of those methods was actually directly imaging and looking at the vessel. That's what this fluorescent image is showing here. So following the surgery, we're going to take samples of the lung, one of the lobes of the lung, cut it, section it, and then stain it, and then look at it under a fluorescent microscope. And this here is a sham lung, so this is from a sham rat, and you can see this green is staining against glycocalyx. So anytime you see green, think of the actual glycocalyx matrix. That's what that's showing. Here, zoomed in, is actual one endothelial cell that I put in a box. So you can see the blue is actually the nucleus of the cell, and then the green is actually the matrix around the cell. So it's a pretty cool image. Now the other method that I talked about in the intro was looking at the actual level of a particular glycoprotein in the plasma of the blood. So looking at the concentration of that protein. And that protein, or that glycoprotein, is called syndikin 1. So throughout the procedure, we took blood samples, and then we're doing a simple ELISA and measuring the actual level of syndikin 1 in the blood. So I talked about glycocalyx shedding is bad. Okay, green equals glycocalyx. More green is good. Less green is bad, right? For the levels of syndikin, more syndikin in the blood is bad. That means it's being shed off the glycocalyx into the plasma of the blood, okay? Less in the blood is good, okay? So I'm going to talk about that in the results. Now, these results don't have any of the DMSO data, okay? This is just looking at the comparison between the hemorrhage group and the sham group, okay? So the sham was that group that didn't undergo any hemorrhage. They didn't have any blood pulled out of them. They did have the procedure, though, the cannula placement, the catheter placement. The hemorrhage group, the HR group, had hemorrhage, but they didn't have any DMSO. So they should theoretically have a lot of damage. And this is true. So this is a graph showing the sham group versus the hemorrhage group against the actual intensity of that green, so the intensity of the glycocalyx. You can see here, the hemorrhage group has significantly less glycocalyx intensity compared to the sham group. Okay, so this makes sense. This goes along with our hypothesis that hemorrhage causes glycocalyx shedding. Okay, and here's a visualization of this graph. You can see here, sham, a lot of green, hemorrhage rat, not a lot of green. Okay, so let's look at what DMSO did. Did it actually prevent glycocalyx shedding? And yes, it did. So this is the same graph with DMSO data added on. You can see here that the HR DMSO group has a very, very significant higher intensity of glycocalyx. Okay, you can see here the green is much more bright, a lot more intense. And this is actually the syndikin data, so that concentration of that glycoprotein in the plasma of the blood. I talked about how an increase is bad and how a decrease is good. And you can see here the black line for the hemorrhage group goes up, right? So that means more shedding has occurred. But what's interesting, this red line indicates the DMSO trials, and they actually, if you're looking at baseline versus the end of the actual procedure, there's no significant difference from baseline concentrations of syndicin in the bloodstream, which means the syndicin stayed on the endothelial cells and didn't actually end up getting shed into the bloodstream, right? So DMSO has a protective role. It's protecting against glycocalyc shedding. Okay, so I'm going to talk very briefly about the actual biochemistry behind why we might think that DMSO is preventing glycocalyc shedding. So the pathway from hemorrhagic shock all the way down to glycocalyc shedding is pretty long. It involves a lot of different enzyme activations and protease cleavages and all that stuff. But one aspect is a decrease in membrane fluidity of the endothelial cells. So it's all about membrane fluidity. Okay? DMSO has been known, the first paper came out in 2007 to increase membrane fluidity at certain concentrations. So the bad thing, if the thing that causes glycocalyc shedding is a decrease in membrane fluidity, and DMSO increases membrane fluidity, that's all that's going on. So it's actually pretty simple. And this is what this little graph is showing here. So hemorrhagic shock, we get a decrease in membrane fluidity, we get some shedding, DMSO increases the fluidity, and we prevent the shedding, okay? So these results possess clinical significance because if we can decrease glycocalyc shedding, as the DMSO does from the results, then we can potentially improve trauma patient outcomes and start to alleviate all those bad coagulopathies that result from shedding of the glycocalyx. So the very next step, the immediate next step would be to do trials on larger mammals, so on pigs, just to ensure that there's no variation in data going from a small mammal to a larger mammal. Okay, thank a couple people, Dr. Bucolo for being my sponsor for my thesis and assisting me with editing my thesis. But this work took place at Tulane Medical School. I worked in Dr. Jackson Weaver's lab for about 3 years now, so thank you. I'd like to thank Aditya and Farhana for helping with the DMSO trials. And funding came from American Heart Association for a 2019 grant. So that wraps it up. Any questions? Yes.
Hi. I remember a DMSO being toxic to the cells at, if I'm not wrong, 0.1% concentration. So y'all are using it at much lower concentrations?
It's at 200 microliters per kilogram.
Which I wouldn't know how much that is, but...
It's very low.
So it's much lower than
yes,
you know
yes,
that what causes
yes,
toxicity
yes,
much lower.
And DMSO has been used in the past for other, like, I think for cancer trials actually. So
yeah,
it's been used as a therapeutic.
Okay, not very successful in that, but the DMSO at some, those concentrations causes like changes, genome-wide changes in microRNA and things like that. So I'm guessing because we're trying to save a life, we're not really interested in other stuff that's happening?
Yeah, just for the acute scenario is what we're looking at.
Okay. So did you look at other organs of the rat, that what might DMSO have done since you, I didn't catch what kind of injection was it, IV, IP?
It's IV.
Okay, so what happened to other organs?
So for the DMSO trials, we only looked at the lung. We do look at other organs for other drugs, but we're just looking at the lung. We will do trials for other organs, though. Yeah, we're going to look at that, yes.
You mentioned DMSO is a really good solvent, but it's such a good solvent, I would worry about the purity. What are you doing to make sure that your DMSO has no impurities that are actually causing this effect?
Well, it's pure DMSO. Well, it's not pure, but I'll have to get back to you on that.
All right, time for one more question.
Yes.
What is DMSO acting on that it decreases the fluidity of the cell?
Well, I actually have to get back to you on that as well. But it does decrease the membrane fluidity by lessening the compaction of the phospholipid bilayer.
Anybody who is a speaker today and your mentor, if you'll come down, we're going to take a quick group photo.
Alright, student presenters, up front. Up here. Amrita,
you're short, get in the front.
come here.
Well, I think they need to.
Sorry.
Oh, just.
You're not that young anymore.
No, not, it's been a long time. Yeah, come on. How are you?
Look at everybody.
I'm like, I'm not a professor, I was a student. She did so good.
Okay, now the advisors get up here. Come on, y'all stay. Y'all stay.
I really almost asked him
She did, but I did my picture. Oh, yeah? Thank you. All right, let's take a break.
Where's the professional
And then 6 months to it.
Yeah, I believe it.
Y'all are done with this. I'm hitting y'all up. I'm hitting y'all up with a big one. Alright, good. Later today.
No, you're right. I got it.
Come on. Y'all need to send me these too, because I need them for Can I get a Bucalo Lab real fast photo, please? Thank you.
Get Isabella's possible.
Hang on a second. Get up here. Ray, come up here.
Isabella's possible. Wait, no.
Hang on. Thank you. I need a Bucalo Lab. Thank you. These things scattered like well. Thank you so much.
Very small.
What? I'm up here again? Yeah, that's awesome. Give one without me.
Make sure
Yeah, I'm sure you've heard it like 7 times. Translatable to like $7 billion. More stress than all my
If there are any people speaking later and you want to come look at the equipment to get a little comfortable with it, I can show it to you right now. We still have a few more minutes. Let me put this down.
All right.
And then you have an option everyone is using this. I had that one. Oh, and then as far as so there's a clip.
But you can also feel positive. Everything.
Oh, that's good. I'm not a 20 minutes. You're 15. You were surprised that you were pregnant. I've never seen like all semester I was making sure that my stream was
I feel like what I didn't tell you is that I'm living until my birthday, so you see me hold it for 3, I should just
that was good. Just like you.
but it's always different. Yeah, I think you said sorry.
All out.
Start. She said, Mom, I'm supposed to sing.
I'm Dr. Kim Mix in the biology department. I'm going to be moderating the next 2 sessions. So our next speaker is Kathleen Coolidge. She has done research in Dr. Dada's lab. And the title of her talk is The Role of Fat Adherence in Metastatic Breast Cancer.
Thank you all for coming, and thank you, Dr. Mix, for that introduction. As she said, the title of my project is The Role of Fat Adherence in Metastatic Breast Cancer. So before I begin talking about what fat adherents are, the first thing I want to talk about is why studying cell adhesion molecules is important in the implications of cancer. So cell adhesion molecules are important for cell-to-cell adhesion as well as cell-to-matrix adhesion. They are in charge of regulating the polarity of epithelial cells. So epithelial cells have what's called basal to apical polarity, or apical to basal polarity. So the apical side binds to other cells, and then the basal side binds to the cell to the extracellular matrix. So in cancer, there's a process in which cells transform from this epithelial cell into a mesenchymal cell, which is called EMT, or epithelial to mesenchymal transition. What happens is these epithelial cells lose their cell-to-cell adhesion properties as well as their apical to basal polarity. And so they become this mesenchymal cell and have planar cell polarity, so side-to-side polarity. So what this does is that it allows these cells to better invade and migrate throughout the body to other tissues. And it's an important process for metastasis in cancer to occur. So the reason why this is important is because fat adherents are a type of cell adhesion molecule. And so we wanted to study their implications in metastatic breast cancer. And so in humans, there are 4 fats that are evolutionarily conserved: fat1, fat2, fat3, and fat4. So fat was first discovered in Drosophila in 1920. It was a lethal mutant phenotype in which the flies that possessed this phenotype had short and fat bodies, so hence where the name fat came from. Fat1 in humans was not discovered until 1995, which kind of just shows just how novel of a discovery fats are in humans. Fat2 was discovered in 1998, Fat3 in 2002, and Fat4 in 2005. From the early 2010s till now, there's been a ton of studies about their implications in cancer. Most of these studies show that they have tumor suppressive roles. However, there's more and more studies showing that they have oncogenic roles as well. And because of this, fats' roles in cancers is still not well understood. They seem to have temporal dependence, which means that their functions are dependent on the stage of cancer, as well as spatial dependence, which means the type of tissue affected also implicates their role. And so we were interested in studying the fat cadherins in metastatic breast cancer. And so we hypothesized that the silencing of these fat cadherins would decrease migration invasion and cell proliferation in metastatic breast cancer. And so we wanted to use a model to test this hypothesis. The model we used was MDA-MB231, which is a triple negative breast cancer. This means that this type of cancer does not have estrogen receptors, progesterone receptors, or human epidermal growth factor receptors. So what basically this means is that this type of cancer does not rely on the body's hormones to grow and proliferate. So it's a highly metastatic and aggressive type of cancer, and a good model for us to use to test our hypothesis. And so I'm going to share with you some previous data that our lab did before I go into our most recent work. So first, we performed bioinformatics work through the use of the Kaplan-Meier plotter and found that high expression of fat1 and fat4 led to significantly decreased survival rates in patients diagnosed with triple-negative breast cancer. So then we used this data and decided that we wanted to mainly work with fat1 and fat4. So first we performed an RT-PCR to look at fat1 and fat4 expression in metastatic breast cancer as well as non-metastatic breast cancer, and found that in the metastatic breast cancer, fat1 and fat4 expression was significantly increased. So then we performed a knockdown assay in which we silenced the fat1 and fat4 genes, and we performed an RT-PCR to ensure that this knockdown was successful, which it was. As you can see, the knockdown fat1 cells, fat1 expression decreased, and then in the knockdown fat4 cells, fat4 expression decreased. We then performed a cell proliferation assay in which we tracked cell proliferation over a 7-day period, and in the cells with fat1 and fat4 silenced, there was a decrease in cell proliferation over time, meaning that these genes may have a function in regulating cell proliferation in metastatic breast cancer. And then we performed a migration and invasion assay and found that in the cells with fat1 and fat4 silenced, there was decreased migration as compared to the controls, meaning that fat1 and fat4 likely have implications in functions in metastasis. So this leads us into our most current work, my work. So all this previous data was conducted using a control that was simply just MDA-MB231 cells. And the only issue is with comparing cells that have undergone a transfection process and a silencing or a gene knockdown, and comparing it to cells that have not undergone a transfection process, is that you don't necessarily know if that transfection process decreased growth and migration and invasion, or if actually silencing those genes causes a decrease in all those things. So we wanted to minimize any confounding variables, and so we created a new control cell line, which we called SH control, which basically was just a scrambled plasmid that did not contain any silencing factors. And then we used this control to compare silencing fat1 and fat4 on the effects of migration, invasion, and cell proliferation. And then we also collaborated with Dr. Emmanuel Ruiz and performed bioinformatics work to better understand fat cadherin's role in metastatic breast cancer. So first we performed a transfection experiment where we took a shRNA control plasmid and transfected these cells. This plasmid did not have any silencing capabilities, so no genes were silenced. And we called these cells SH control cells. We then took an shRNA FAT1 plasmid and transfected cells, which we called SH FAT1. And then we took shRNA FAT4 and transfected cells, which we called SH FAT4. We then performed an RT-PCR to confirm that this knockdown was successful, but we found some pretty interesting results. So as you can see, in the cells with FAT1 silenced, FAT1 expression decreased as expected, and in the cells with FAT4 silenced, FAT4 expression decreased as expected. However, when looking at the cells with FAT4 silenced, FAT1 expression increased, and then when looking at the cells with FAT1 silenced, FAT4 expression increased, meaning that when you knock down one fat gene, it is likely that the other fat gene upregulates to compensate for this knockdown. We then performed a cell proliferation assay in which we looked at cell proliferation over a period of 3 days. And as you can see, in the cells with FAT1 silenced, there was decreased proliferation over a 3-day period, whereas in the cells with FAT4 silenced, there was not an effect on or a decrease in their cell proliferation. We then performed a scratch wound assay. So we took densely packed cells, or also known as confluent cells, and inflicted a scratch where we opened the gap here and left them to incubate for a 24-hour period. We used a live cell imager, also known as an INCI site, to track over every 2 hours this INCI site took pictures, and so we use that to document growth. So when this experiment basically looks at migratory properties of these cells, and so over time, the more filled in this space is, the more invasive the cell is. So this is what it looks like. It's kind of hard to see, but we got results over here. So if we follow this yellow line, we can see that in the cells with FAT4 silenced, wound confluence was at its lowest, meaning that middle gap part was the least filled over time at the slowest rate. If we look at the cells with FAT1 silenced, they're also lower than their control rate, which basically indicates that FAT1 and FAT4 may have a role in regulating migratory properties of these metastatic breast cancer cells, and then this bar graph kind of just depicts what's shown in the line graph up here. So I'm going to pivot a little bit and talk about some bioinformatics work that we have done. We collaborated with Dr. Emmanuel Ruiz from the Louisiana Biomedical Research Network, and we're super grateful for her help. So we looked at the TCGA data portal, which is a data portal with thousands of real clinical samples from cancer patients. We had told her the implications of fat in cancer. However, we did not tell her any of our results to avoid any biases that she may have. And we asked her to look at all the breast cancer samples available in the site, which was over 4,000 cases available. And so she provided us with a plethora of data, but we're still in the process of navigating through and analyzing it. So I'm just going to show you a small snippet of it. So this looks very confusing, but I'll explain what this all means. So this is a multivariate regression analysis that takes into account the fat genes and compares it to different parameters that you can set. It also takes into account age, gender, and race into these correlations. So if we look at the key over here, we can see that purple circles means that there's a positive correlation, and pink circles means that there's a negative correlation. And then the bigger the circle, the more significant that correlation is. And so basically what we had seen is that FAT4 is positively correlated with invasive lobular carcinoma and inversely correlated to invasive ductal carcinoma. So invasive lobular carcinoma is a very metastatic breast cancer, whereas ductal breast cancer is a less metastatic or subtype of breast cancer. So what this tells us is that FAT4 is highly expressed in the more metastatic breast cancer subtype as compared to the non-metastatic breast cancer subtype, which really is big for our lab because that really just confirms everything we have been seeing in our experiments, and that FAT4 likely has a role in regulating migration and invasion of these cells. And then over here, this tells us that all the fat genes, so FAT1, FAT2, FAT3, and FAT4, are positively correlated with EMT, or as I said before, epithelial mesenchymal transition, which also serves as an indication that these 4 genes are involved in regulating the metastatic properties of breast cancer. And so we concluded that FAT1 and FAT4 regulate migration and invasion in triple-negative breast cancer and may play a role in metastasis. We also concluded that FAT1, FAT2, FAT3, and FAT4 promote EMT and may regulate metastasis through the data we saw in the GTC. And then we also concluded that FAT4 is positively correlated with lobular breast cancer, whereas it's negatively correlated with ductal breast cancer. And so some future directions, we'd first like to find a new FAT1 and FAT4 antibody to perform more protein analysis work. So we've been doing a ton of Western blots, and we've been seeing a lot of non-specific bindings, so we were trying to troubleshoot as to why this is, and we're looking into other companies to see if their antibodies possibly work better. We would also like to repeat our invasion and migration assay, as well as our scratching assay, and then we'd like to parse through all the FAT4 specific clinical data by finding a ductal specific breast cancer cell line, as well as a lobular specific breast cancer cell line. And then we want to investigate the role of fat cadarins in EMT and planar cell polarity. So thank you to everyone in the Dada lab. Thank you to Dr. Dada for taking me under your wing for the past 2 years. Thank you to Megan Samara and Isabella Elias for being great mentors. Thank you to Amy Martin, Cindy Barnett, and Anna Keller for taking on this work after I graduate. And a huge thank you to Dr. Christopher Williams and Dr. Hagen Kim for everything you've done for us. Thank you. We would not have been able to do this without you. Thank you to Dr. Emmanuel Ruiz for all the bioinformatics work that she performed. And thank you to Dr. Mix, Dr. Anderson, Dr. Jordan, Marty, Rose for all the resources, advice, and assistance you provided for us. And then we're appreciative of all the funding we have received by the DeKerning Grant, the Bio Department, the Dean's Office, and the Provost's Office.
How do you think the fat adherents are regulating migration? Do you have any theories on what they might be doing mechanistically?
So, I mean, based on what we've seen, hold on, I really gotta think about this one. I think they have implications in directing planar cell polarity. I think they have a role in the whole EMT process. So that's actually a future direction of what we're wanting to look at possible EMT markers and B9s. And so, I'm excited to find out more as to how they regulate migration. So.
Research was sponsored by Dr. Dada here at Loyola, and she conducted research at LSU Health Science Center and with Dr. Xavier. She's not here, but let's give her a round of applause. I'm not sure that's right.
I might need help with this. Bucola, weren't you showing me this earlier? This is the recorded over the, you're supposed to just click there. It's going to the drive. Yes, it's going to my drive down there, that's right here. It's that, just the
Hi, my name is Kay Morris, and I will be presenting my research on exploring cognitive impacts of Parkinson's disease and multiple sclerosis.
Press it every time. Sorry.
Hi, my name is Kay Morris, and I will be presenting my research on exploring cognitive impacts of Parkinson's disease and multiple sclerosis.
All right, while we figure this out, sorry, we did have it playing earlier and it's disappeared, so I don't know where the one we tested is. So bear with us. You shouldn't have to zip undo it. Maybe just download it again. Go to the URS presentation. That's just slide one. So go over to that folder. So the first folder, URS presentation.
Okay, got it.
And then download the whole thing. Yeah. Anybody use this ever in their classes? Because it worked earlier, now it's not working, and I don't know if it's troubleshooting of it. No? Do you do the slide?
What's that recording thing up over there?
That would be if you recorded it. I played it earlier and it played just fine. Yeah, that's it. Press that, it's taking you to that folder. That's what I was saying. That's done. Yeah.
But it's only giving us slide one. It's only giving us the sound of those live.
Hi, my name is Kay Morris, and I will be presenting my research on exploring cognitive impacts of Parkinson's disease and multiple sclerosis.
Can't do it on
Yeah, it says can't load audio right now.
Come back later.
The smart students who know technology better than us said download it as a video. See if that works.
Need to go on an island, I think.
allows you to download it in what
I think
saved
that's
us.
just when you go to it on PowerPoint.
You got this.
Do the same.
There's always hiccups, so, you know, adapt or die. Yeah, she did put timings on it. I'll take
Thank you, Kaya, for your research. We're sorry we weren't able to share it right now. We'll provide an alternative opportunity for you all to check out your work. So we're going to move on to our next. Should we wait? Okay, so we can wait a few minutes and get her slides ready, and then we'll move on.
In case somebody's planning to come at 3:15 for our next speaker, we'll go ahead and just take a 5-minute break so nobody misses her, and we'll get rolling. It is
And I was like, yeah, and I just know.
We have plenty of programs down here at the front if anyone walked in from the back, came in. Feel free to come grab the program, it has all the abstracts and docs.
I'll have to say that. Good job.
All right, thank you all for your patience. Just a reminder, there's refreshments in the back. We have coffee and water and some toys. So please help yourself to that as we move through the rest of our schedule. So our next speaker is Jillian Nicosis. And she did her research in Dr. Anderson's lab, and she's going to present the results of that work focused on somites, muscle, and regeneration of chicken joints.
All right, thank you, Dr. Hey, good afternoon, everyone. Like she said, I'm Jillian Decasas, and I'm talking about somites, muscle, regeneration, all of chicken joints, a whole lot of different topics, but I'm gonna bring it all together, hopefully. So here's a quick little overview. I'll give you a pretty hefty background on a little bit about muscle, somites, why we're even using a chicken, and then talk about my methods, what I found from those methods, and an overall conclusion summary, and the future of this project. So just starting out, why are we even studying the possibility of regeneration? We don't really regenerate any tissue. And so there's a lot of things that affect joints, muscles, ligaments, tendons, and especially the elbow joint, which is what I was focused on. So among those are limb amputation or overall loss, neuromuscular disorders, autoimmune diseases, all can make life very difficult when it comes to moving your muscles, moving your joints, things like that. There are some cases, though, in the animal kingdom where regeneration is possible, and regeneration is different from healing. So I just want to clarify that too before I go too far. When the tissues heal, so you get some kind of wound or injury and tissue heals, there is scar tissue. It's not an exact replica. It doesn't come back quite the same. But regeneration is essentially redevelopment, starting basically from scratch, the same method that tissue developed originally in the embryo or the fetus. And so there are some creatures that can do that, some salamanders, some amphibians that can completely regenerate limbs after losing them. Obviously, though, that doesn't happen with us, but there are some small kind of phenomena that is reminiscent of that. And so one thing I kind of noticed just in my research while I was getting background for what I did was about satellite cells. So most of y'all are probably familiar with stem cells. Satellite cells are basically stem cells, multipotent cells that are found under muscle fibers to regenerate muscle after some kind of loss of those muscle fibers. And so they stick around postnatally. They're essentially going through that same regeneration, redevelopment process. And so seeing things like this happen, seeing actual regeneration happen in the animal kingdom, and all of these instances over here where regeneration would make life a lot easier for a lot of people, to me that is a worthwhile cause to look more into this topic. And so talking about this topic, we are looking at the elbow joint mostly, and obviously cannot go ahead study in humans right away, so we look to the embryonic chick as our main animal model, our embryonic chick in Gallus gallus. And so we picked this because it is a really good bridge, I think, between mammals and vertebrates. It is also a vertebrate, also a tetrapod, and although not a mammal, it develops in a very similar manner to us. I have up here Hamilton stages of chicken embryo development and some examples of human embryo development. And just looking at some of these stages, there's some that you probably couldn't even tell apart. I couldn't even tell apart. Additionally, there are some good advantages to studying a chicken. They're very accessible. They develop outside of their mother in a little eggshell that is fairly inexpensive, develops very, very quickly, so kind of easy to study. Not easy, but a pretty good option. Before I get too far into the actual methods that we're studying, I want to give you a bit more background on where muscles come from. We're talking about muscle regeneration, so we have to start with muscle development. We have been looking into cells called, not cells, but structures called somites. And they kind of look like this right here, where these red arrows are, or this structure right over here. And they are pretty fascinating. They're these paired segments that develop alongside the neural tube, so one on each side. Neural tube, which will become the spinal cord. And they're just jam-packed full of tissue, little bundles of tissue or of cells that will migrate to various locations in the body to become muscle. So we're very interested in them, especially this dermatome region kind of around here, where it will migrate into the limb and develop skeletal muscle down there, as well as our satellite cells. And this happens at a very early stage. Hamilton stages 14 to 18, which is 50 to 69 hours, so a broad window, but kind of lasts for a long time. We're still figuring that out. There's still a lot of mystery with these things, but after these cells migrate, they start the process of myogenesis. And hopefully most of y'all are kind of familiar with this. It is a pretty straightforward process where these stem cells, somatic cells, kind of go along the way, eventually become myoblasts, where they proliferate and proliferate and proliferate until eventually exiting the cell cycle and reaching terminal differentiation into myofibers here. Right around this stage here is where we're going to look at a little bit later on, looking at some myosin. But one thing I do want to point out, it's not the topic of my study, it's not what I really got into, but what I think is interesting and kind of affirms some facts about regeneration and development is just looking at these genes that are present at all these situations. And so the initial myogenesis from these somatic cells into myofibers, as well as postnatally satellite cells becoming myofibers, all of that kind of involves PAX3, PAX7, similar genes across the board. And so when we look at muscle regenerating later on, I'll get to future direction, but this was kind of significant to me just to think about. So, we do know that muscle regenerates, and that's something I will get into. And the objective really was to figure out how does it regenerate. We know that myofibers are reaching terminal differentiation when they are lost or injured. Postnatally, satellite cells can, in a way, bring them back or regenerate them. But when we see it in our embryonic chick, in our animal model, is it due to proliferation of existing cells, of existing myoblasts or myofibers, or could it be migration from these somites, considering these somites, that's their job, is for cells to migrate from them and form muscle. So we really want to explore what is the mechanism for this regeneration. And then this is the overall methodology. This is what we did. So we first started with egg preparation. We received our eggs, and after 2 days of incubation, we prepped them, removed a little bit of albumin from inside,
2 days after that, at day 5 of incubation, we performed the window incision and technical microsurgery that I will get into. Following that procedure, we fixed our tissue, embedded it, sectioned it, and performed immunohistochemistry, which I'll also talk a little bit about. So this window excision, looking back, one of the most fascinating things to me, it is what it sounds like, window excision. We're excising a little window right here in right around the elbow joint, actually where the joint will form, we know from fate mapping, sorry. It's about 150 microns or micrometers across, and this is done again at day 5 of incubation. And any time after that, we look at multiple time points following that. But right here, I have day 12, so 1 week after this surgery. And in our control, this is our reformed elbow joint, or what will be the elbow joint, currently cartilage in the embryo. And then following the window excision at the same time point, that joint is still present. So the joint itself is regenerating, which is absolutely mind-blowing to me still. But we don't know yet, just looking at that joint, if it means anything, right? Could it actually be used? Is it functional? From that, we would have to look at the muscles, ligaments, tendons, accessory features around that joint. And so again, I focus mostly on muscle. Other students have focused on other topics. But to look at the muscle surrounding this elbow joint following the window excision, we use immunohistochemistry. But if you are not familiar with this process, it is essentially an immune reaction where you pick an antibody to target a specific antigen or whatever protein you want to look at. And so we're trying to look at muscle. So the protein we're looking at is sarcomeric myosin. Sarcomeric myosin is only found in mature, differentiated muscle fibers. And then we pick an antibody called MF20, which specifically targets that sarcomeric myosin. And so the whole process of immunohistochemistry, we pick this primary antibody of MF20, we use a secondary antibody, and then to recognize that primary antibody, and then some kind of color substrate to produce a color where that muscle is. And so you can look at a picture like this and see if this rust orangey color is our muscle. One thing I want to say, we've done this experiment so many times in the past, and we'll probably do it a whole bunch of times more. We have used different substrates though. So in this picture, our muscle is this dark brown, orangey, rust color. There are some pictures where it's a more bluish, dark purple color due to our substrate use, and I'll make sure we kind of keep it straight what is what in all our pictures. So we do the window excision, the joint comes back. What about the muscle? Do the immunohistochemistry. This is what we find. That muscle does regenerate, it does come back. Here we can see triceps brachialis on both of them, and a couple other muscles not pictured here. This is a day 12 embryo control and window excision, and those muscles do come back, as well as some tendons here too. So we see this muscle comes back, this muscle does regenerate. These are kind of the first results that really cemented the window excision as a kind of standard procedure in looking at muscle regeneration. How does muscle regenerate? And so following this really cool finding, muscle does regenerate. How does it happen? Well, I wanted to look to these somites and see what that contributes. So this is the more recent work we've done. I graduated though in December, so it's not quite as fresh as it used to be. So much more things have been done since. But personally, I was able to find some good pictures of somites. So I have a day 4 here and a day 6 embryo here. Just to give you some perspective, this top up here is the dorsal side on all my pictures, while down here along the bottom is the ventral side. In these images, that dark purple, dark blue color is our muscle. So you can see some of it up here, some of it here, and then a whole lot of it around our somites here. So red arrows are pointing to muscle, while our blue arrows are again pointing to these somites. Somites are usually paired, so we're just seeing one half along what would be the neural tube, probably somewhere down here. This muscle on top will be the dorsal muscle. This muscle down here we know will be the trunk muscles. But one thing to note is that there's only somites in one of these pictures, so one of the limitations of the study is kind of orienting that tissue. And so no somites, unfortunately, in this image, but we do know, of course, they are present somewhere.
Here we have some pretty good images of both the somites and the limb muscle. Next to the developing limb right here, somites in these blue arrows, back muscle here, limb in here, so just kind of reorienting us. And this slide shows a little bit more about muscle following the window excision, 3 hours post-surgery, a huge gap right here, missing tissue, while 6 hours post-window excision, so much tissue has filled the gap, as well as muscle and this rust color. So overall, what are my findings? I do know that somites do contribute cells to muscle in multiple locations, and this is not a brand new finding. I did not discover this, but I was able to provide a bit more evidence for this. I also do know that during the window excision, muscle cells are removed. We do know that they are removed because we also do see them regenerate following that window excision. We were able to also observe dorsal muscle maturation, so going back to that day 4, day 6 picture, we know this is all dorsal muscle right here, and we see a pretty big increase in that. And then what I think is the biggest takeaway from what I was able to find was that somites are present at the stage that the window excision initiates regeneration. So when that regeneration does happen, when that muscle, all that tissue does return, somites are still present. They're still stuck around at that time. So there is a possibility that they can be contributing. Kind of hard to say though, because there's so many future directions I would love to take this in. I'd like to get some better techniques in dissecting and orienting that tissue to see if we can see somites, limb muscle, everything all at once. I would love to identify somites and muscles a bit earlier on. There's so many different ways we could have attacked this. We started with muscle just because we were doing limb muscle for a while. So we saw the muscle in the back next to somites, but I would love to see some other markers, as well as labeling the somatic cells and watching how they migrate, when they migrate, where they migrate, the entire journey. I would love to thank Dr. Anderson for being the most amazing mentor. All of my lab partners, Bailey Wynn, Milo Lacoste, Sophia Paz, Caitlin Montoya. I'd also like to thank the Malahi Undergraduate Research Fund and Loyola University New Orleans for allowing me to do all of this and learn all of this. Thank you so much.
Why don't you prep the egg the same day you do the surgery?
Why don't I prep the egg the same day we do the surgery? So we prep the egg at 3 days of incubation and then do the window excision at 5 days incubation. And any later than that, we found that the embryo and the albumin and everything inside kind of sticks to the shell. It makes it very difficult to successfully perform microsurgery and move around in there, manipulate anything inside of there. So any earlier or any later would just be a bit too difficult. Okay, thank y'all so much. I haven't seen Bailey. Oh, there you are. Okay, I missed you. Good. Come on down. Do you want to hold this or put the level on?
Thank you, Jillian, for a great talk. We're going to continue our theme of looking at muscle regeneration and growth in the chick system with more research from Dr. Anderson's lab. So our next speaker is Jillian Wynn, who's not only a star researcher, but she's also a leader in Phi Beta, the Honor Society here at Loyola, so she's our treasurer.
Okay, thank you so much, Dr. Wynn. Hi everyone, my name is Bailey Wynn. Today I'm going to be talking to you about muscle migration during regeneration. So to go into our presentation outline, we will be starting with our introductions and methods, and we'll be finishing with our results and conclusions. So firstly, with our introduction. In looking at muscle regeneration as a whole, the definition of regeneration is the process of replacing or restoring an organism's structures and tissues to a point of full function. And if you look at this right here, this is actually a salamander regenerating its limb over the course of about 5 weeks. Salamanders serve as a really great model for regeneration, as they are able to regenerate their limbs no matter how that limb was injured or lost. And the process of regeneration actually follows a series of developmental events. In our case, in particular, we are looking at the elbow joint of a chicken embryo. And the significance of the study is to understand the regenerative process of muscle can lead to treatments and cures that can help better improve a human's movement and overall quality of life. And then in looking at the chicken embryo as our model, there exists a lot of similarities between chicken embryos and human embryos. They share a lot of morphological structures as well as similarities with their mechanisms in their processes of evolutionary things with their genes and cells. And chicken embryos are also incredibly accessible. They're easy to manipulate as well as observe a fast development. And also, if you look at this picture, this is the chicken embryo on your left, and the right is the human embryo. And with that, it helps us get a really great early understanding of embryology of vertebrates. And then when prepping our eggs before we incubate them, on the 5th day we perform something called a window excision surgery. Basically, in this process, an incision is made and the anterior surface in distal 150 microns, and it removes this section of tissue, and in that section of tissue is included the humerus, radius, and ulna. And when we do the surgery, it still doesn't impair the way the joint develops. It's able to develop normally after the surgery is performed. If you look at these images, you can see a lot of the supporting structures of the joint are present. So we have in the red, that's the muscle, humerus, radius, and ulna are the skeletal elements that are also labeled. And yeah. And going into somites. So somites, they are paired, repeated embryonic structures along the neural tube. They bud off from unsegmented mesoderm, and they're transient and used in early development. What's significant about somites is that the cells from somites can migrate into the limb to form skeletal muscles. So additionally, they also contribute to vertebrae, ribs, dermis, and skeletal muscle of the back and body wall. And they begin forming anteriorly, and they are added posteriorly as the embryo extends. So the anterior ones are more developed, meaning that in an embryo there's just a wide range of somite stages. And in looking at PAX3 and PAX7, those are just important regulators of muscle development, and they're expressed before the muscle differentiates. So with all that being said, it still leaves the main question of where are these muscle cells coming from in the limb? So does the regeneration of skeletal muscle come from pre-existing cells at the wound site, or are they replaced by somites? And then going into our methods, so after the embryos are prepped with a window excision, they are fixed and then sectioned. After sectioning occurs, we do this process called immunohistochemistry. So that is what, with immunohistochemistry, we use antibodies to detect protein in our tissue. This photo up here shows kind of the short rundown of immunohistochemistry. So firstly, a primary antibody. In our case, we use MF20. It binds to the antigen. In our case, we are looking for the protein myosin. On our histological sections, the second step is a horseradish peroxidase linked secondary antibody, binds to the primary. And lastly, we add a coloring substrate, so we use DAB, and it produces a color product, and that product is insoluble and permanent. So if you look at this section right here, it's showing the red. This is positive detection of the sarcomeric myosin, so showing that our immunohistochemistry was positive there. And also here, you can see I've also labeled some of the skeletal elements, humerus, radius, and ulna as well. And the counterstain that we use in immunohistochemistry is hematoxylin. Going into our results. So with these representative sections, we have early stage embryos from 3 hours after the window excision surgery is performed and 6 hours after. The red arrows indicate where we are seeing the detection of muscle. With the 3 hour, if you look at this like blue thing right here, this is the window excision site. As you can see, it's actually already filling with cells, and it's also, we know that it does end up filling by the later stages of this embryo, that it fully fills with cells. But you can see there's muscles right here. These muscles that are like in these circles, they are going to contribute to the back of the embryo. So we also don't know if those would contribute to the limb. That's still something that we're determining, but as you can see in the experimental, there are still muscles being shown. In the control, you can see the muscles here as well as in our experimental. And same thing, I will mention that maybe another thing that could go along with the reasoning why we might see more muscles in our control than our experimental could just be the specific section with our sectioning techniques. I'm not showing too much of the muscle yet. And then for these representative sections, this is 24 hours after the window excision surgery and 48 hours after the window excision surgery. It's really great for these because you can see like the muscle that's formed here are actually in places where we would expect specific muscular structures to be. So also, same thing, the skeletal elements are developed here, humerus, radius, ulna are all here. And then to think of like the overall outlook of it and going back to somites, the things that we were mentioning earlier, if you look here, this section right here, this kind of shows a positive outlook on our immunohistochemistry because there's parts of the heart being stained in red. So MF20 also recognizes cardiac muscle, so we saw this as a positive control in the fact that we know that the heart contains muscle, and we're seeing that being stained here with the atrium, ventricle, and ascending aorta. And then the way in which these sections were done, as you can see, they look a little different from the ones we saw earlier with just the limb. We had oriented these embryos in the wax to be sectioned in a way that we could see the whole embryo when we were sectioning. The only downside to it is that we weren't able to observe the limb in our sections when we oriented the whole embryo. However, it's still positive because you can see the somites along the neural tube in both of these sections, as well as with our immunohistochemistry is promising because, like I mentioned, the staining of the heart, but also we could see some muscles in our sections as well. Now going on to our conclusions. So repopulation of muscle cells has occurred within the limb of the regenerated joint. The window excision did not impede the formation of muscles, and somite contribution to the regenerative muscle of the limb is inconclusive just because of the difficulty of obtaining sections with both the somites and the limb. And so with this being said, we were able to see muscle development, but of course it still requires further investigation on the repopulation of those muscle cells and where exactly they came from. And so future approaches wise, this study sought to set a great foundation for the observation of muscle development and regeneration in the elbow joints of chicken embryos. And further research on this topic could be amplified possibly by analyzing known genes to visualize muscle cells at their earliest stages of development. And so with that being said, MF20, the antibody recognizes differentiated muscle and not muscle precursor cells that could be present at the time of incision, so possibly doing a study to focus on the more earlier precursor cells. And then another way that it could be amplified is by changing the orientation of the embryos when we're embedding them in the wax to improve how the overall limb is being observed. And acknowledgement-wise, I of course want to thank Dr. Anderson for being such a great mentor and a line of support. And then of course to all the students in the lab, Colton, Caitlin, Jillian, Mila, Sophia for working on this research with me, and to the Malahi Student Research Fund for allowing us to do all of this. And my references. Any questions?
So we have 3 minutes for questions.
how would I measure proliferation of muscle cells? So yeah, in this instance, I would say probably if another study was done, it might be good to do proliferation of cells can be measured by cell markers and cell division, like seeing cells divide. So with that, you could do immunohistochemistry again, probably with a Ki-67 along with your immunohistochemistry. So it would be like a double labeled immunohistochemistry. So we'd still like do the MF20 to myosin to detect myosin, but then at the same time, we could do something at the same time with those markers. I would say probably a good way would be immunofluorescence, so like marking those with fluorophore to see the presence of both of those in a cell, basically. Yeah. Any questions?
I know you mentioned your experience, your experiments positive control. What was the negative control?
Our negative control was when we performed immunohistochemistry, but instead of placing our primary antibody, which was MF20, we replaced it with a buffer. So basically no staining was observed when we had done that.
I was curious what the significance was of using the cardiac muscle as a positive control.
Yeah, so with MF20, I had mentioned that it is positive in staining cardiac muscle, and there's no like significance to like our overall thing of it being with like studying limbs. But of course, like information like that is beneficial because we know that our process of immunohistochemistry is really promising because we know that the myosin is being detected in our slide. So showing that as a positive landmark, and just in case anyone was got a question on why the red was up there, kind of describing that it's because it's being detected by MF20.
Would you consider your research a success?
We didn't answer the question, but I would still say that it definitely was a success. We were able to do all of our methods, and it worked out in the ways that we wanted it to. I think too, it makes me excited because it lays kind of a foundation for like the future research that's going to continue with the students in our lab, and hopefully they can take this and continue on with that as well.
Any more questions?
Yeah, how are you guys able to detect like, the migration cells?
Okay, so yeah, migration would be different in the sense where you would see, basically you could mark the cells. I'm actually unsure. Basically, it'd be kind of like the same process where you would mark those cells that you're looking towards. So from the cells leaving the somites, you would mark it with something in particular. I can't remember exactly what I would use as an example, but basically you would label those cells with the process probably, and then you would allow them to migrate, so you just incubate it for a little bit more, and then you could probably compare the same thing with, if you did normal immunohistochemistry and looked for myosin, you can kind of like overlay the images of like cells with myosin, but also if you mark the migrating cells as well from the somites. Questions? Thank you.
You're done. That was really good. Oh my God. I was up there.
Good afternoon, everyone. My name is Isabella Daniel, and today I will be presenting my research project.
Oh yeah, because you're not bio. They still have to send it back. I knew it. How's he? He's good. He's actually going to Nowhere and everywhere. That was lined up perfectly.
They got talking.
No, it was all day. Because I was still like the time. I felt like I have never been able to.
I tried to get away to most scandals and
the amount of pushback I get is astronomical. Well, this semester we didn't have that many people. But no, that's crazy. I will petition
All day's cool, I aspire to. Also, I like some of the
And then finally, it's like.
What's up? Like yes. You already walked. Cool, send me the link because I already got the letter. Oh, not right now. Since I already have the problem, me neither.
of Salem here.
Alright, welcome back. We're going to go ahead and get started with our final section. The talks have all been wonderful so far. We're going to bring it home with the last 5 talks of the afternoon. So our next speaker is Anna Hernandez, who did her research in Dr. Walkenhorst's lab in biochemistry and chemistry. And her talk is going to focus on antimicrobial activity of silver nanoparticles.
Hi everyone. So as many of you may know, there is an ongoing problem pertaining to antibiotic resistance. And as we can see in this figure from 2019, from a study done in 2019, there are around 5 million deaths per year associated with antimicrobial resistance, which is comparable to data found from deaths for other for other diseases such as HIV, AIDS, or malaria. And because of this, our work focuses on testing for effectiveness of combination drug therapies. And in past work, others have used AMPs, which have exhibited synergy in combination with toxic ions. So a promising area of research for us was utilizing silver nanoparticles, or AGMPs, because these have been widely used as antimicrobial agents as well. So in our research, we are testing for the antimicrobial effects of copper, zinc, and silver in combination with AGMPs against common bacteria found in hospital-acquired infections. So first, I would like to present the 3 gram-negative bacteria that we've been working with. First one is E. coli, then Pseudomonas aeruginosa, and Burkholderia tyladensis. So gram-negative bacteria exhibit a 3-layer cell wall, which consists of an outer membrane called the lipopolysaccharide layer, a thin peptidoglycan middle layer, and an inner cytoplasmic membrane. compared to the 1 gram-positive bacteria that we utilized, which was Staphylococcus aureus. And these type of bacteria have is much simpler. They have 2 layers in their cell wall consisting of a thicker outer peptidoglycan layer and then an inner cytoplasmic membrane. So for getting into the basic structure of the AGMPs we used, we can see that they are comprised of a silver metal core, which is then has capping ligands attached to it, and in this case we use chitosan, which is a positively charged polysaccharide, and this possesses antibacterial properties which are being studied as potential natural antimicrobial agents, as these are found in the shells of crabs and shrimp. So even though the exact mechanism of AGMP toxicity is unknown, they still are able to interfere directly with the cell wall and may also release silver ions into the cell, which then generate reactive oxygen species like hydrogen peroxide, which in turn interferes with cellular functions such as the disruption of the DNA replication. And so the ions that we used, which were copper, silver, and zinc, are known to inhibit the electron transport chain and interact with biologically important sulfur groups, giving way to the reactive oxygen species, which again damages DNAs and proteins, which eventually would lead to cell death as well, as shown in this figure. And basically, this is our setup. We utilized a 96 well plate to collect our data, and the clear wells indicate that the bacterial growth was inhibited so that the bacteria did not continue to grow overnight after the treatment, and the cloudy wells show the bacteria are completely overgrown. So we started by adding the reagents to this top row right here, and then we diluted them downwards by a factor of 2 progressively, so that whenever you were going down the plate, then the concentrations would be lowered. And from this, we can derive the MIC, which is the minimal inhibitory concentration, which is signified by the last clear well of each column. And this lowest concentration just signifies the lowest concentration needed to kill the bacteria in the wells. And this can be seen right here. The MIC for the AGMP was well D1. For the ion by itself, it was C2. And for synergy, it can be seen right here. So basically, in this experiment, the data collected was divided into 4 repetitions of 3 columns. So the columns, column numbers 1, 4, 7, and 10 contained the AGMPs by themselves, while the columns 2, 5, 8, and 11 contained the ions by themselves. And columns 3, 6, 9, and 12 tested for synergy. So again, the last clear well of each column gives us the MIC for the AGMPs and the ions alone. But in the synergy column, since they were mixed together, we have both species present at half concentrations, generating two MICs for the AGMPs and the ions. So from this minimal inhibitory concentration, we are able to derive fractional inhibitory concentrations, or FICs, which are basically the fraction of 2 enzymes. And so the last clear well of the synergy column, the MIC of that would be divided by the concentration of that species when it was by itself. So for example, the FIC of the AGMP is the concentration is derived from the concentration of the MGMP when it was combined with the ion, divided by the MIC of the AGMP when it was by itself. And similarly, the FIC of the ion is the concentration of the ion in combination in the synergy column, divided by the MIC of when it was by itself.
And furthermore, we can add these two values and obtain an overall activity, which is then used to interpret the synergistic effects. So, for example, in this table, we have the values across the top. So if you have an FIC value that is lower than 0.5, it is considered to be synergistic. If the value is anywhere between 0.5 and 2, it is considered to be additive. But if it's anywhere between 0.5 and 1, it's technically considered to be strongly additive. So anything in the range of 2 and 4 is considered to be indifferent, and anything above the range of 4 is antagonistic. But regardless, most of our data showed it to be synergistic or additive. So in this graph, what we can see is the FIC of the AGMPs in the x-axis and the FIC of the ion on the y-axis. The different colors represent the different bacteria used, and the different symbols represent the different ions used, always in combination with the AGMPs. So the way that we interpret this graph is that anything below this red line right here is considered to be synergistic, and anything below, in between this red line and black line, is considered to be strongly additive, and anything above that is considered to be additive or indifferent, but our values were lower than 2, so technically they would just be considered additive. But again, since our results were mostly additive and synergistic, the two synergistic points can be seen right here. The green triangle represents the synergistic effects between the silver nanoparticles and the silver ions for Staph aureus, and the purple circle represents the silver nanoparticle synergistic effects between copper for copper with the AGMPs for butyllate denses. This next graph is basically just a simpler representation of the previous graph. The 3 ions are on the x-axis right here, and the FIC values are on the y-axis. And again, the different colors for the bacteria, just code for different colors for the bacteria, my bad. And the shortest purple bar means the synergistic effects between copper and the AGMPs for butyl, while the green bar right here codes for the AGMPs in synergistic effects with the silver ions for Staph aureus. And this is just an alternate way of displaying our data. In these tables, I'm showing basically all of the data that we've compiled up until this point. So this table right here is for copper, this table here is for zinc, and then I have a third table, for this is copper, silver, and then this is zinc. And so basically we can derive the FICAs by dividing the AGNPC from the AGNPA, and as well, same goes for this middle portion, and then the addition of the FICA and the FICB is what gives us the FICC, which is and then used as the interpretation for declaring synergistic effects or strong additivity. And the N right here basically means the number of times an experiment was repeated. So for pseudo, it was basically repeated 40 times, and for E. coli 23, butyl 28, and then Staph aureus basically 52 times, and same goes on for the rest of them. So in conclusion, we found synergistic effects between silver nanoparticles and the silver ions for Staph aureus, which is the gram-positive bacteria. And we also found synergistic effects between the silver nanoparticles and copper ions for the gram-negative bacteria, Loculnaria tyloidensis. And this just suggests that combination therapy may be a promising treatment for both of them, for both gram-negative and gram-positive bacterial infections. And so I would like to personally thank Dr. Walkenhorst for being my mentor through this process, as well as Delaney and Jonathan for being my research partners through all of this, as well as Dr. Heineke and her research students, Elise June and Elise Ward, who synthesized our AGMPs for us that we used in our experiment.
We have a couple minutes for questions. Any questions for anyone?
So how do you know that when you, let's say, it reaches a point where you're treating the patients who have these infections, how will these agents act in the actual human cells? Because they're killing bacteria, how do they know how to differentiate between bacteria and human cells?
So right now, I think we're mainly focusing on like topical implementations of these of the synergistic effects. We're still not, I'm personally still not sure if in vitro usage would be of, you know, I don't think we can do those just yet, but topical implementations of those or like oral rinses and stuff could probably be of more use than using them inside still, but yeah.
Any other questions?
Is there any specific reason behind, aside from just having some gram-positive and some gram-negative, the specific bacteria that y'all picked for this study?
Yes. E. coli, pseudo, and staph are bacteria that are very prevalent in hospital settings, basically, and infections comprised in hospital settings. So the only one that isn't found in a hospital setting would be B. tai, because this bacteria is not, it's, the actual bacteria's name is Burkholderia pseudomallii, which is often found in Southeast Asia. And that particular strain of the bacteria is what is like responsible for a lot of diseases. So we're using like a more safer strain model that we are able to use in our lab, basically. So yeah, I hope that answered your question.
It does, thank you.
Great. Thank you, Anna.
That's it.
Okay, our next speaker is Anna Upman, who did her research in Dr. Mirabel's lab in neuroscience. And the title of her talk is Beyond Trauma, Examining the Psychosocial and Neural Correlates of Emotional Processing.
Hi, everyone. My name is Anna Upman. And yeah, I'm going to be talking today about examining the psychosocial and neural correlates of emotional processing in relation to trauma. So I wanted to start by giving kind of a brief understanding or introduction of what trauma is. Trauma has to do with an emotional response to stressful, frightening, or distressing situations, often that are difficult for us to fully process. So with that being said, some examples of trauma would be serious car accidents, exposure to violence, illness, and natural disasters, which most people here would be familiar with. Given that people's experience with trauma alters a lot based off of the person, that means that how people react in the aftermath of trauma is also quite different. And trauma is quite common. The majority of Americans are going to experience at least one traumatic experience in their lifetime, meaning that most people in this room have at least had a traumatic exposure. After trauma, most people will recover from their trauma, but a small subset of people will develop a chronic set of symptoms known as PTSD, which most people are familiar with. PTSD is quite well known, and it's pretty well understood of what's going on in the brain during PTSD. On the other hand, there's another small subset of group of people who will experience a positive transformative growth after trauma. And those people have something termed post-traumatic growth, or PTG, which is the focus of our study. The neuropsychological markers of trauma are important because they let us know what's going on inside of the brain. And when it comes to PTG, it helps us understand and promote resilience. And if you're wondering how exactly do we define PTG, or how do we measure it, we can look at it in a variety of dimensions. And so there's 5 main dimensions that we look at that people can experience positive changes in. And so it starts with appreciation of life. And a way that people can experience that is by having a greater appreciation or value of their life, or appreciating each day in ways that they didn't before. Relationships, or improvement of relationships, which might develop a sense of closeness with others, increased compassion, or knowledge that you can count on others in times of crises. Life possibilities are new possibilities, and these can be such as defining or developing new interests, a new life path, or willingness to change things that might need changing. Spirituality, which would be a deeper understanding of spirituality or stronger faith than you had before the traumatic event. And personal strength, which is just the knowledge that you can handle difficult things and that you're stronger than you thought, or have stronger self-reliance. So post-traumatic growth can be shown in a variety of different ways, as we've mentioned. And if we think about it in the way of hurricanes again, as most people have experienced that, we can think of it as if an individual had experienced a hurricane, was displaced by it, and had traumatic experiences due to that, and afterwards decided to pursue graduate school as a result, or defined closer relationships, or had greater appreciation of life. And that would be examples of what PTG is. So if we look at what exactly we are studying, our study aims to examine the associations between PTG and the neural correlates of emotional processing alongside altruistic behavior using EEG. If you're unfamiliar with how human subject research is done, which a lot of the research today I know has been more biological and cell-based, what we do is we go ahead and bring participants into a lab and we have them do self-report measures. These are validated surveys and questionnaires that give us a good idea on questions that pertain to emotions or subjective human experiences. Afterwards, we hook them up to an EEG machine, which tells us what's going on inside of the brain, and we give them different tasks. For our study, we give them a facial processing task, and then we will analyze what's happening inside of the brain. In our lab, we use EEG, or electroencephalograms. So we know that the brain communicates via electrical signaling of neurons. And so what we can do is we can record that activity inside of the brain using an EEG cap that has electrodes that we place all along the scalp, and it amplifies those signals. An individual is then given a task, the facial processing task in this study, and we look at ERPs, and these are event-related potentials. So ERPs are just time-locked EEG data that surrounds a certain stimulus and is averaged among many, many trials. And so for this study, that would be, they are averaged based off of the facial expression that they're exposed to. So a facial processing task looks something like this. The individuals are presented with a variety of different faces. Most of them are going to be neutral, so around 75%. A quarter of them are going to be emotional faces, and of those emotional faces, we're going to split it about 50% into positive faces and 50% into negative faces. And these faces are presented at about 1,000 milliseconds per face. And we just ask participants that they press a button every time that they see one of these infrequent emotional faces. And when we're looking at the EEG, there's a part on the electrode cap called P8, and that's located right around here, and it's correlated with the temporal lobe. And that has to do with the fusiform face area, or the FFA. And that part of the brain is highly specialized in processing faces. So we look at it because we know that it's going to have greater activity. When we look at all of the ERPs, for all of our participants at P8. You're going to see all of these little squiggly lines, and if you're wondering what that is all of the electrical activity blocked around that certain stimulus. And so we had 24 adults aged 18 to 27, all with traumatic exposure come into our lab. And the black line you see is going to be the grand average of the average responses to presented stimuli for neutral faces. The blue line will be for positive faces, and the red line will be for negative faces. So when we're looking at ERPs, we can kind of look at different components of them. And the two main components we're going to look at is our amplitude and our latency. Amplitude is the height or voltage of our electrical signals, just how big or small they are. Latency has more to do with the timing of this, and so it tells us more about how long it takes in milliseconds for stimulus information to generate a certain component of an action potential. You can look at different peaks, and in our study we chose to look at P1, N170, and LPP. P1 and N170 are related to early sensory processing, and LPP is related more towards later cognitive processing. So when we look at our PTG dimensions and our ERPs and emotional faces, you see that we found results for both our P1 and our LPP peaks. And when we're analyzing it, we need to look at both our peaks separately. And so we split it here into our P1 and our LPP, and then from there we went ahead and split it into our two ERP components, which would be our amplitude and our latency. Because we're trying to see, does the size and the timing affect what's going on here? And we can see that it does. So to go ahead and kind of look at it in a better way, we went ahead and put it into scatter plots. So to start, we're going to look at our P1. And so we see as appreciation scores increase, we have a decrease in amplitude. And similarly, as LPP scores, or as appreciation scores increase, our LPP amplitudes decrease. And what that means is that as our appreciation scores increase, we're seeing that the brain is using less neural resources at both that early sensory stage and that later cognitive processing stage. And when we move on to latency, we're going to see that as spirituality scores increase, we have a decrease in latency scores, meaning that we have a quicker response or a quicker processing of emotional phases at that later cognitive functioning. So overall, we're just seeing quicker processing with fewer neural resources when it comes to certain PTG dimensions. And if you're asking yourself, what does all of this mean? We're going to go ahead and look at trauma as a continuum. In the middle, you're going to have most people, and that is the average American that we talked about who will experience something traumatic and be able to recover from it. They're going to have average amplitudes and average latencies that we see. On one end, as literature has supports, we have, for PTSD, increased amplitudes and later latencies or longer latencies to emotional stimuli. And that has a lot to do with the symptoms that you see in PTSD, which reflect greater sensory or emotional reactivity. On the other end, we have the opposite results of what we found in our study of PTG, or post-traumatic growth. And that's decreased amplitudes and shorter latencies to emotional stimuli, which means that we have reduced sensory processing and reactivity of facial expressions. So what we're getting is kind of a continuum and a greater picture of what's happening in trauma in the brain overall. So we have the beginning of an understanding of how PTG affects brain processing. But our next step is to kind of examine how it affects behavior. So we asked, does PTG predict altruism or helping behavior? And a lot of things can predict altruism, and a lot of those have to do with traits. And traits are things that stick with us throughout our life, and so they're unlikely to change. And so a couple of those would be empathy and our ability to cope under stress. And so when we control for both of those traits, we see that PTG does still significantly predict altruism or helping behavior. When it comes to the potential implications of this study, we can start with the fact that PTG is quite under-researched. What we know about PTG has more to do with how somebody might experience PTG or what might lead to somebody developing PTG. But we don't know a lot about what's happening in the brain or how it affects our behaviors. So we're allowing for more research in the actual understanding of brain and behaviors to be out there. And with that knowledge of what's happening in the brain, we can help with the treatment of PTSD, as we're kind of seeing that there might be an opposite activity in the brain. And if we have more research and more understanding of what's happening in PTG, we can promote resilience and potentially help treat PTSD. Mindfulness is also a very good example of how appreciation of life and spirituality can be used in everybody's everyday practice. Mindfulness is quite a hot topic right now in psychology and in pop culture. I'm assuming a lot of you have heard of it, and if not, it's quite a simple way just to be mindful about every day. And those tie in a lot with appreciation of life and spirituality. And so we're kind of seeing how that might also affect the brain and changes, which all has a lot to do with neuroplasticity as well. I want to go ahead and say thank you to all the support that we've had. A special thank you to Dr. Yergel for all of her support that she's given me over the last 4 years and in the lab, and to everyone else who helped with the study. And I'd be happy to take any questions.
Hey, I want to congratulate you on a very smooth talk, and I just had a quick question. Could you go back to the slide where you have the ERP waveforms?
With which one?
The slide with the waveforms?
Yes.
With the color code? Because from what I saw, it looked like, so a neutral stimulus in black can be differentiated from a highly emotionally reactive face, whether that's an appetitive or an aversive, or I guess a positive or negative valence emotion face. Can you tell between blue and red, if from the ERP wave, if the person is reacting to a positive face versus a negative face, and make some sort of index of a bias towards positive faces or negative faces?
Yeah, so we mainly kind of grouped emotional faces all together when we looked at it. So we kind of looked more just at positive and negative faces grouped together. You can see that there is a little bit of a difference. I don't think from what I remember that it was statistically significant enough for our study. That being said, I think it depends a lot on the subset of group of people you have, the traumatic exposure that they have, and also the number of participants you have. That would all kind of vary that and allow you to better understand or see if there are more significant differences in that. But for our study, we mainly just looked at emotional faces versus neutral for that.
Thank you.
I think mine's related to kind of the same question. Because, yeah, the one thing I saw is the red looked like the amplitude for negative faces was bigger, around 150 and 400 milliseconds.
Mm-hmm.
And I was just wondering if that was, if that was just a known effect, that you have a bigger amplitude for negative.
In PTSD, you'll see there's a lot more well known in literature that you have higher reactivity to negative faces. And so we kind of, I don't know exactly, PTG is understudied, so I'm not exactly sure how it kind of goes over. I also know that we're working right now to see, there's LPP can be split into two components, so later LPP and early LPP, which we're working on right now. And that would give us a better idea of if that's more significant, because you can see there is a higher peak there, but we haven't done all the analysis of that yet.
Thank you.
Priming effects on motor learning and EEG analysis on readiness potential and event-related desynchronization.
and I'm here to talk a bit about my research. So before starting, let me ask you a question. What do you guys think is the basis of life? Some might be thinking it's breathing, others might be thinking it's heartbeats. But what if I tell you that the true answer to this question is actually movement? If you think about it, nothing really happens until something moves. And when I talk about movement, I don't necessarily refer to exercise or physical motion. Rather, I am talking about the movement as the language of the brain, which in neuroscience we refer to it as neuroplasticity. Neuroplasticity refers to our brain's ability to reshape itself, purely based on changes in our environment. If you think about the brain, think about it as a dynamic network of neurons that is constantly changing structurally, chemically, and functionally based purely on what you think, feel, or do. This flexibility allows us to learn new abilities, recover from injuries, and adapt to changes happening around us. And it should come as no surprise that neuroplasticity is the basis of motor learning. Whether we try to walk, learn how to play a sport, or play an instrument, through repetition and doing movement, throughout time, we get to make this more precise and efficiently, strengthening the neural pathways that are associated with this type of action. But what happens when we lose this ability? And why I am saying when instead of if when saying the statement? Well, because if we take a look at the latest statistics within the United States, circling the three major causes of brain injuries that lead to motor deficits, which are spinal cord injury, traumatic brain injury, and stroke, we are seeing that there is a projected prevalence of these type of disabilities that is going to increase by 12% by 2030. How is our healthcare system supposed to keep up with this upcoming increase when, as we can see, there is currently already staggering statistics surrounding us? Well, the answer to this question relies on the increased global demand for neurorehabilitation therapies. Born from the principles of neuroplasticity, neurorehabilitation is a multidisciplinary practice that aims to enhance the recovery after a nervous system injury. Basically, what we're trying to do is focus on recovering function and enhancing quality of life of patients. Our brain works in mysterious yet very fascinating ways, and especially when it is dealing with damage. What if I tell you that after brain injury happens, there is a period of time where our brain's neuroplasticity gets heightened? This crucial period involves the brain trying to reroute neural connections through using unaffected neurons that will help restore functions of the skills that are lost through brain injury. This critical period is referred to as the therapeutic window, and it is the place where neurorehabilitation takes place through three key steps. First, there is initial contact with the patient. Providers are trying to assess what type of treatment and the severity of the injury in order to conduct this assessment. Then we focus on trying to restore the pre-illness connections of the brain by harnessing the ability of neuroplasticity. And finally, we work on maximizing this functional recovery based on the new limits of the disability. However, even when utilizing these techniques that aim to harness the brain's innate ability to heal itself, neurorehabilitation is still known as one of the hardest types of recovery. So what makes the science and practice of this type of recovery so challenging? Well, this is because our brain makes a really good job at tricking us, especially into thinking that things that we believe are simple are actually extremely complex when it comes to the brain organizations. If you need an example, just think about making a fist. As babies, it takes us around 5 months to fully grasp and hold an object, let alone learn how to walk, or even perform the complex motions we do as an adult. So imagine the amount of time and repetition it takes us to relearn these skills as adults after brain injury. Furthermore, a brain injury works as a fingerprint. None of them is alike. So each patient is going to require a unique and tailored type of treatment. And the length of recovery will vary appropriately. In fact, this length of recovery is so subjective that it depends on key factors, such as the severity of the injury itself, the individual's overall health, and the overall response to treatment. You see, neurorehabilitation is a highly demanded billion-dollar industry. However, it also corresponds to one of the most prolonged and costly interventions available. And this makes an incredible challenge for our population, since neurorehabilitation can vary from months to years to even having to do it for a lifetime, leading to unmanageable costs for the population. This leads us to trying to find new ways to battle these challenges. And one of these promising avenues that are coming across is motor priming techniques as a novel approach for neural recovery. So what is motor priming? Motor priming is a technique that basically prepares the brain for learning and movement. By providing targeted sensory input or repeating motor tasks, motor priming facilitates the activation of motor circuits that overall makes it easier for the brain to respond to subsequent motor learning and rehabilitation therapies. To illustrate this concept better, consider the process of learning how to ride a bike. Before jumping into a bike, we tend to practice our balance, or we resort to training wheels. This serves as a stimulant that helps our brains familiarize with the sensations and movements associated with biking. By activating the appropriate muscles and neural pathways, this preparatory phase makes it easier to transition to biking when it's time to move from this type of training. Two popular priming techniques that are being used in neurorehabilitation is motor imagery and action observation priming. These are non-invasive techniques that bypass the need for extremely costly equipments. And instead, they harness the power of specialized brain cells that are called mirror neurons. Mirror neurons, as the name says, function like mirrors. They activate when we perform an action and when we observe someone else perform the same action. So through mental rehearsal of movements, motor imagery, and action observation, they aim to activate these mirror neurons and overall prepare our brains to learn and understand our desired movement more efficiently, leading to improved performance in neurorehabilitation exercises. However, despite its potential benefits, motor priming in neurorehabilitation is still not a complete solution. Research indicates motor priming often fails in reducing the amount of time and duration of neurorehabilitation, contributing to the lifelong cost associated with this type of therapy, and it emphasizes the need of innovation in the field. So how about using short-term priming instead? Unlike traditional motor priming methods conducted over extended periods of time, short-term priming applies the same principle but in brief spaced intervals. This approach is not only looking to offer enhanced flexibility for therapy intervention, but it also maximizes therapeutic time without losing efficacy. Recent studies, in fact, are beginning to explore this type of short-term priming, and even the University of Science and Technology in China developed this therapeutic model that involves interventions with short-term tasks, followed by trial repetition sessions, which have shown very promising results in reducing the duration times of neurorehabilitation. However, short-term priming still faces a significant obstacle for its clinical application, being that the exact duration needed for priming is yet to be determined, and this is the purpose of my study. In this study, we're utilizing electroencephalography to examine the timing needed to induce a priming-evoked change in a motor learning response. By conducting a time and frequency analysis based on recording brain electrical activity, we're looking at two potential markers, readiness potential and event-related desynchronization. Readiness potential represents a gradual increase in neural activity of certain motor cortex before voluntary movement initiation. It basically refers to the brain's preparation for action. While event-related desynchronization is a decrease in brain oscillations in terms of power and amplitude, and it corresponds to cortical excitability that happens when we are increasing neural processing, hence when we're performing the movement. To analyze these markers, we are utilizing a weighted analysis. This is a method that offers a flexible representation of electroencephalography signals using mathematical functions that can capture both brief events and frequency changes over time. This approach allows us to examine changes in neural activity and across frequency bands, providing information in the locations of readiness potential and event-related desynchronization during priming. When looking at wavelet plots, we see red and blue colors. What does this mean? These involve an increase and decrease in cortical excitability respectively. And it helps us understand all of the signals within different frequencies and time points. As this study is currently ongoing, we will be focusing today on the initial stages of our analysis, particularly using wavelets to explore a general overview of how neural activity is changing in response to priming. So how are we doing this? Through utilizing the therapeutic model previously demonstrated in short-term priming research, we're choosing participants to be instructed to observe motor imagery videos that correspond to the flexion and extension of both the right and left elbows, with each motor imagery period lasting 6 seconds. Following this period, we are assigning participants randomly to one of two conditions, a prime and a baseline. What we're looking to do here is that we are varying the resting period duration between conditions in order to investigate its impact on our markers, specifically since this time frame is what represents motor planning before movement, and it is where we believe priming may have the most significant influence. In the priming condition, participants are experiencing a 3-second rest period before being asked to perform a motor action, while in the baseline condition, participants undergo the original therapeutic model, which includes a 6-second rest period before performing the motor action. This sequence is repeated for a total of 40 trials divided into 2 equally distributed sessions. Each session focuses on the flexion and extension of either the right or the left elbow. These sessions are also separated by a 5-minute rest period in order to allow the brain to rest and reset for the second priming session. This is basically for quality of data control and to optimize participants' performance. So for analysis, we're paying particular attention to electrical activity within the electrodes sitting at the primary motor cortex, which is the area of the brain responsible for planning, executing, and controlling voluntary movement in the body. So what is our weighted data so far? So far, we are focusing solely on the right elbow flexion and extension in our analysis, but we are observing notable changes in neural activity within the primary cortex as expected, with a particular emphasis at electrode in the temporal location 7 during the prime and baseline conditions. In the prime conditions, we are noticing a distinct increase within the beta frequency range, which is utilized to visualize cortical activity related to motor planning and execution. This searching power depicted by the prevalence of reds in the wavelet analysis prior to performing the movement suggests heightened neural activity or synchronization in the cortical area associated with motor planning before movement initiation. Conversely, in the baseline condition, this enhancement in the beta frequency is visually present but less pronounced. Now, some of you might be thinking, why is reducing the time by 3 seconds such a big deal? Well, these findings are suggesting that reduction in the time frame needed for the brain to perform motor planning by 3 seconds is actually inducing the brain to rapidly adapt to this altered condition, potentially enhancing neuroplasticity, thus explaining why we're observing a more prominent effect in cortical activity during the priming condition rather than the baseline. And actually, if this isn't exciting enough to know that we are contributing to findings that prove short-term priming as an accurate intervention for neurorehabilitation, these findings are also helping us have impactful applications in various other fields. For instance, short-term priming is currently being explored as a novel method for telehealth in occupational therapies, having the potential to significantly reduce costs associated with travel and hospital services, making it more accessible. And moreover, our study findings offer valuable information for brain-computer interface development. Once beginning to map in the shortest amount of time needed to reach the readiness potential in our analysis, we will gain insight into the time range of motor reactions, as indicated by the peak of the readiness potential. This understanding will address a key challenging prosthetic design, aiming to synchronize reactions with user intentions effectively through targeting where is motor planning happening specifically. In essence, we are really trying to see short-term priming as a future of neurorehabilitation. And through all of the interventions that we're making, we hope to shed light on how to make better techniques that make this practice more accessible. Thank you very much.
Thank you, Viviana, for a great talk. And we're going to move on just to schedule. So if you have questions for Viviana, you can catch her after the session.
Hi guys. Good afternoon.
Our next speaker is Trinity Martin from Dr. Schofler's lab, and the title of her talk is Testing the Importance of Local Amino Acid Enrichments in Extremophilic Homologs.
Hi started talking. Okay, so what are extremophiles? Extremophiles, like the name suggests, are organisms that inhabit environments that are intolerable for most life forms. So that is including but not limited to environments with high acidity, salinity, alkalinity, and acidic, salinity. That also includes environments of very warm and very cold temperatures. So for the purposes of this study, we want to study how proteins from these extremophiles have evolved to become stable in these harsh conditions. Studying how they become stable in these conditions and have great interest in biotechnology. For the purposes of our study, we are focusing on thermophiles, which are bacteria that live in extremely warm and extremely cold extremely warm environments, and cytophiles, which are bacteria that live in extremely cold environments. So, our model system to study extremostability in proteins is an enzyme known as DNA gyrase. So gyrase is a type 2 topoisomerase that is responsible for inducing topological changes in bacteria DNA that's responsible for DNA replication, transcription, and repair. Topological changes are necessary for those cellular processes. The gyrase in particular is mostly known for its ability to negatively supercoil bacteria DNA in negatively supercoil relaxed plasmid DNA in vitro. This is an ATP-dependent reaction that involves the cleavage and subsequent repair of a double-stranded segment of DNA. And here, as you can see, this is a what relaxed plasmid looks like, and this is what a negatively supercoiled segment of DNA looks like, and this is what gyrase does. It catalyzes this reaction. So gyrase has two subunits. It has a gyrA subunit, which is this structure in green at the bottom. That's the DNA binding and cleavage site. It also has another subunit, gyrB, which is the ATP binding and hydrolyzing site. For the purposes of our study, we are focusing on gyrB. So, I want to reiterate that we wish to understand extreme stability in proteins, and we did that by two approaches. Our first approach is a bioinformatic approach, and I'll explain what that entails right now. So, first we obtain the gyrB amino acid sequences from thermophiles and saccharophiles, thermophilic and saccharophilic homologs. Then we calculated the local and global amino acid enrichment for all 20 amino acids in each region of the sequence. So at this time, I want to point to you the difference between global amino acid enrichment and local amino acid enrichment. So global amino acid enrichment focuses on the enrichment of a certain amino acid in the entire sequence, while local amino acid enrichment focuses on the frequency of a specific amino acid in each site of the sequence. So like this, what this figure is demonstrating right here, we're more focusing on this approach rather than this one. So, our next step is to visualize the amino acid enrichment differences between thermophiles and saccharophiles using an in-house detection protocol called Symposium. More on that later. And finally, we are locating the most differentially specialized sites in a 3D structure of gyrase that has been published in E. coli. And so this is our result for the first site of interest. Our first site of interest is near a really highly conserved site, known as the Switz lysine. So the Switz lysine is a conserved residue in gyrase that associates with the phosphate group in ATP. And in this region, we found that it is highly enriched in glycine residues and thermophiles. So right here, I'm going to walk you through these two results, what you're seeing. So on the left, this is the 3D structure of gyrase in E. coli, and this is the specific site that we're looking at. This black box here is the Switz lysine. And in here, this is our SlideCamp analysis. So what you're looking at on the x-axis, you have the alignment position, and on the y-axis, these are delta values, which calculate the amino acid frequency difference between thermophiles and saccharophiles. So essentially, if a value is positive, that means it's enriched in thermophiles. If it's negative, that means it's enriched in saccharophiles. So right here, the star region is the region that we're looking at, and this is where we find an influx in glycine residues and thermophiles that is kind of unexpected because previously established literature associate high glycemic enrichment with psychophilicity. Our next site is the transducer region. So this region is of high importance because it is responsible for the conformational changes that gyrase undergoes following ATP hydrolysis. Here we found that there is an enrichment in serine residues and psychophiles, as you can see here in green, and alanine residues in thermophiles. This region right here. E. coli, we also found that this region was enriched in serine residues, as this black box is denoting here. So our last site is the GRB cap region. It's located around the apex of the enzyme. Unlike the other two, this one has no known catalytic role. And here we found an enrichment of charged, negatively charged amino acid residues, glutamic acid and aspartic acid, and thermophiles. So here is the enrichment right here. And in E. coli, we also found something similar. This little cascade of magenta residues. These are all negatively charged. Like glycine, negatively charged amino acids are also affiliated with psychophilicity. So this was another really interesting find. So that concludes our bioinformatics portion. Our next portion involves more of a wet lab oriented approach. And here we did multiple temperature dependent activity assays to test the activity of Escherichia coli gyrase. Now, Escherichia coli, E. coli, is a bacteria that thrives in moderate conditions. So it's defined as moderate temperature conditions, So it's defined as a mesophile. So here, we grew large amounts of E. coli, harvested their gyrase, and subjected the enzyme to multiple activity assays, temperature-dependent activity assays. And here's what this process kind of represents. Here is our relaxed plasmid that's circular. We mix the relaxed plasmid, which is our substrate in this reaction, with our enzyme. And after 30 minutes, we incubate that at a specific temperature for 30 minutes, and depending on whether those temperature conditions were favorable or not, we expect to see supercurling. That's what this little mini sign is representing. After 30 minutes have concluded, we stop the reaction with SDS and EDTA, and once the reaction stops, we visualize it on a gel electrophoresis plate. So the reason we do this is because relaxed plasmid actually has a different banding pattern than supercoiled plasmid, or supercoiled DNA. This is what relaxed looks like, this is what supercoiled looks like. So if we see the presence of this in anywhere on a drill, we know that the enzyme is active at that temperature. So here's a more descriptive version of what we did. So essentially this reaction was done in a 96-well plate for better control. We also had varying concentrations of our enzyme, higher concentrations on the right, lower concentrations on the left. And here is our SDS and EDTA respectively. And in the second panel, I'm just showing how those two reagents were added to the reaction plate in succession. And here are our results from that. So at 37 degrees Celsius, we actually do see supercurling activity at higher concentrations, starting at around 1.6 nanomolar. This is to be expected because, like I said, this is E. coli gyrase, and E. coli is a mesophilic gyrase, or mesophilic bacteria, and 37 degrees Celsius is physiological temperature, so no surprise here. However, when we go lower at 4 degrees Celsius, you actually see that there's no activity, like even at higher concentrations, no activity at 4 degrees Celsius. This is like a psychophilic condition. And at 50 degrees Celsius, we also see something similar, no activity, even at higher concentrations. What this weird smearing pattern looks like, we believe is a result from the enzyme denaturing and having an effect on how the DNA was visualized, how it ran, essentially. Okay, conclusions. So, in the future, we wish to perform more of these temperature-dependent activity assays on drivers from E. coli. So that's so we can understand the full range of temperatures in which we can see activity. Right now, we know that there's certainly activity at 37 degrees Celsius, and not at 4, and also not at 50. So we want to see the full range of temperatures in which we can see activity, and that's so that we can possibly shift this range, expand this range using mutations that can increase the enzyme's tolerance for cold and warm temperatures. So
How do you do that? We are planning to, in the future, we hope to design mutants based on our bioinformatic analysis that we performed earlier, and then test the mutants with these temperature-dependent activity assays that we saw earlier, and depending if those mutations increase the enzyme's tolerance for cold and warm temperatures, we can hopefully get a better understanding of extremosability in proteins. So, I'd like to thank my wonderful and amazing research professor, Dr. Scheffler. I would like to thank my 2 lab partners, Isa and Julia, for helping me in this journey, and all the other lab members in the Scheffler lab. Also, previous members, Batea, Elliott, and Avery Hill, for their prior contributions, And our research was funded by the Louisiana Board of Regents Research Competitiveness Sub-Program Award. So, yeah.
Questions for Trinity?
This is kind of an ignorant question, but so you have this, you said it's DNA gyrase of these different extremophilic bacteria. Where do you get that? Is it synthetic or?
The DNA, the enzyme itself, or?
Yes, because if you're having some from the different kinds of bacteria, is that just something you can order? Like, oh, this bacteria, this one. Maybe that's a dumb question. I'm just curious.
I mean, here we're just looking at the sequences of the extremophils in like hot and warm temperatures. That can be found online on the database. I forget the exact name of the database. But for our future experiments, yeah, we do wish to, or we are ordering some bacteria from those environments. Usually, I believe, I know thermophiles are usually found in like hydrothermal vents like that little picture I used to at the beginning. And cycrophiles, just tundra.
Any other questions? Let's thank Trinity.
Good afternoon, everyone. My name is Isabella Liano.
Our final speaker is joining us virtually, Isabella Liano, who did her research with Dr. Schofler. And the title of her talk is Extremophilic Protein Adaptation Analysis via Local Enrichments Using Model System DNA Gyrase.
Good afternoon, everyone. My name is Isabella Liano, and today I will be presenting my research project that I worked on in conjunction with Dr. Schofler and her lab. It is entitled An Analysis of Extremophilic Protein Adaptation via Local Enrichments Using DNA Gyrase as a Model System. For this project, we took a biotech standpoint in order to understand extremophilic protein adaptation. This perspective allowed us to identify the overarching issues revolving around engineered proteins and how current bioinformatic determinants are at the root of these problems. Engineered proteins provide various benefits in addition to posing various shortcomings. One major benefit of engineered proteins is found in polymerase chain reaction, or PCR. PCR is a method used to rapidly amplify DNA sequences. Taq polymerase, an engineered protein, facilitates the PCR technique. Its ability to withstand high temperatures while adding nucleotides to DNA strands during amplification make Taq polymerase indispensable in PCR. On the other hand, engineering proteins can be challenging and pose difficulties for several reasons. For one, proteins are incredibly complex molecules with intricate 3D structures that are crucial for their function. Despite significant advances in structural biology and computational modeling, our understanding of how changes in protein sequence translate to changes in structure and function is still incomplete. Furthermore, proteins often need to interact with other molecules in highly specific ways and must maintain their native structure and stability under various conditions. Lastly, experimental techniques for protein engineering, such as expression and purification, can be time-consuming, labor-intensive, and expensive. After thorough analysis, we have attributed these shortcomings to our lack of understanding of current bioinformatic determinants. With the steady increase in sequencing of proteomes, many investigators have analyzed sequence and structural attributes contributing to adaptation of proteins to extreme conditions. However, the results of many of these studies have contradicted one another. I will specifically touch upon the studies conducted by the Met-Pally group and the Yang group. Met-Pally and Yang both conducted studies that calculated the frequencies of amino acids in cyclophilic and mesophilic proteomes. I will first cover Met-Pally's study. In order to analyze the proteomes of cyclophilic and mesophilic microorganisms and their adaptability to their respective optimal growth conditions, Met-Pally examined the composition of amino acids of cyclophilic and mesophilic proteomes in three main secondary structural elements: alpha helices, beta sheets, and coils. Cyclophilic proteomes contain significantly fewer residues in alpha helices and more residues in coil regions. Notably, tiny, small hydrophobic, acidic, aliphatic, and nonpolar amino acid groups like alanine and serine showed significantly high frequencies in the coil/loop regions of cyclophiles. This is largely because cyclophilic proteins enhance their flexibility in low temperatures by decreasing the number and strength of stabilizing interactions. Using Met-Pally's data, I made bar graphs to show the frequency of amino acids in secondary structures of cyclophilic and mesophilic proteomes. In these graphs, if the bar is above the x-axis, then the amino acid is enhanced in cyclophiles. Conversely, if the bar is below the x-axis, then the amino acid group is enhanced in mesophiles. Most notably, Met-Pally found that alanine and serine were enhanced in cyclophiles in all secondary structures. Yang's study on cyclophilic adaptation contradicts this particular observation from Met-Pally. Yang did not find alanine nor serine to be enhanced in cyclophiles in any secondary structure, as shown through the starred bars on the graphs. Yang's results were determined via an analysis of the variations in the amino acid residues of homologous proteins between cyclophiles and mesophiles. These results were then compared with the results obtained from a dataset for high temperature adaptation based on 18 different species pairs. It can be deduced that the difference between the results in Met-Pally and Yang studies is most likely due to the fact that they utilize different genome sets. The research conducted by both Met-Pally and Yang is quite representative of the bioinformatics literature covering the thermostability of cyclophilic bacteria. All of these studies point to the problem of using global metrics to understand cyclophilic adaptation. Thus, this informed our own method. We will use local enrichments and adaptations to investigate and understand temperature adaptation, using the bacterial molecular machine DNA gyrase as a model system. DNA gyrase is a bacterial enzyme that catalyzes the ATP-dependent negative supercoiling of double-stranded closed circular DNA. It is classified as a type of topoisomerase that is involved in the control of topological transitions of DNA. DNA gyrase is composed of two subunits, the gyre A subunit and the gyre B subunit. The gyre A component is what facilitates the enzyme's ability to induce negative supercoiling. A motif in the CTD of the gyre A subunit, termed the gyre A box, is required for the enzyme to carry out this unique function. Since the gyre A box primarily consists of basic amino acids, it can be rationally assumed that the positively charged gyre A box could directly bind to the negatively charged DNA. The gyre B subunit, on the other hand, contains the ATP binding and hydrolysis region at the NTD. The image on the top right is a full 3D structure of DNA gyrase. The gyre A subunit is represented by the teal color. Again, this subunit contains the gyre A box, which contains the site for DNA binding. This is indicated by the arrow. The orange portion of the figure represents DNA that would bind to the gyre A box. Lastly, the gyre B subunit, represented by sky blue, is the site of ATP hydrolysis. So, how does DNA gyrase mediate the strand passage mechanism in order to supercoil DNA? The mechanism starts off when DNA binds to the DNA gate located in the middle of the complex. The DNA then gets wrapped around and reintroduced to the ATP gate on the top of the complex. The DNA in the DNA gate gets cleaved, and the DNA at the ATP gate gets shoved through the break. The segment that got shoved through, which is called the transfer segment, then escapes through the bottom exit gate, and the DNA at the DNA gate gets religated. The net result of this is the conversion of a relaxed piece of DNA into a supercoiled piece of DNA. This enzyme was an ideal model system since DNA gyrase is found in all bacteria. Furthermore, as a large multi-domain complex molecular machine, this project aims to expand the way that the scientific community views protein specialization. Since different regions of the enzyme are going to have different requirements for flexibility and stability, localized differences are expected. Thus, this project's use of local enrichments makes gyrase an ideal model system to successfully study temperature adaptation. Prior students in the lab have commenced the project by gathering gyrase sequences from diverse organisms. For my contribution to this project, I formulated and conducted a gyrase protein purification protocol using an E. coli-based expression system. After obtaining pure gyre A and gyre B, I conducted gyrase activity assays at different temperatures to test the protein's temperature dependence. In order to conduct a successful gyrase activity assay, we had to first purify wild-type E. coli gyrase as our standard. We achieved this by transforming E. coli to culture with a genetically engineered gyrase expression vector that coded for either gyre A or gyre B, a TEP site, and a His4 tag. Once transformed, we harvested, lysed by sonification, and centrifuged the cells in order to remove all of the solid components. We took samples of the lysate and clarified lysate, which was known as the soluble supernatant, to analyze them via SDS page. The clarified lysate was passed over the immobilized metal affinity chromatography column, or the IMAC column. The engineered His4 tagged protein stuck to the nickel column and all of the contaminants flowed through. We then washed the column with a low imidazole buffer to eliminate any residual impurities. Samples of these washes were collected to be analyzed via SDS page. Next, we used a high imidazole buffer to elute the His4 tagged protein from the column. A sample of this eluent was collected for SDS page analysis as well. Dialysis was then performed to dialyze away all of the imidazole. TEP protease was also combined with the eluent to cleave off the His4 tag from the gyre A or gyre B. That material was then run over an orthogonal nickel column. The His4 tag and TEP protease, which also contained an engineered His4 tag, bound to the column, while pure gyre A or gyre B flowed through. All the samples collected throughout this protocol were analyzed via SDS page to confirm pure gyre A or gyre B protein. This pure protein was used for all future gyrase activity assays. The samples obtained throughout the gyrase protein purification protocol were visualized via SDS page. A gel was run for both gyre A and gyre B. For gyre A, the lanes for lysate and clarified lysate had a thick band at the appropriate molecular weight for gyre A, which was 97 kDa. This confirmed a successful expression of the protein in E. coli. However, the protein had various contaminants represented by the thin bands beneath the 97 kDa band in the lysate and clarified lysate lanes. Low imidazole washes were conducted to eliminate these residual contaminants. The flow-through and wash lanes show the eluent from the column during low imidazole washes. The elution lane exhibits the eluent during a high imidazole elution step. This overall process purified gyre A to a nearly homogeneous level. This is shown through the single thick band in the elution lane. Similarly, for gyre B, the lanes for lysate and clarified lysate had a thick band at the appropriate weight for gyre B, which was 90 kDa. This confirmed a successful expression of the protein in E. coli. The protein had multiple contaminants as shown at the bands beneath the 90 kDa band in the lysate and clarified lysate lanes. Again, we conducted low imidazole washes to eliminate these contaminants. The flow-through and wash lanes display the eluent from these washes. However, unlike the gyre A gel, the flow-through here in the gyre B gel contained gyre B. This meant that we exceeded the capacity of the IMAC column. This did not affect the protein's purification, as the high imidazole elution step resulted in a single thick band at the correct molecular weight of gyre B. The procedure used for each assay sought out to determine the concentration at which gyrase activity can be observed, the temperatures at which gyrase activity can be observed, and the temperatures at which the protein can be inactivated, and the ability of DNA gyrase to be more resilient to colder or hotter temperatures. Thus, in order to achieve verifiable results, topoisomerase activity assays of these proteins were conducted at different temperatures. The first few steps of the procedure consisted of creating and aliquoting the reaction stops. The first stop, which was 10% STS, was aliquoted into each well of row D. The second and last stop, EDTA, was also aliquoted into each well of row E. Next, gyrase tetramer was prepared from gyrase storage buffer, stock gyre A, and stock gyre B. A twofold gyrase dilution was conducted in row C. The subsequent step consisted of making the assay mix in a centrifuge tube. The assay mix consisted of a variety of constituents, including relaxed plasmid, ATP, DTT, and assay buffer. Derived from E. coli, the relaxed DNA plasmid was used to determine if gyrase-mediated supercoiling had occurred. The ATP was used as a substrate, and the enzyme catalyzed reaction. The DTT reduced disulfide bonds within the protein. And lastly, the assay buffer was used to maintain the pH throughout the reaction. This assay mix would facilitate a reaction when combined with gyrase. It was aliquoted in wells A1 through A12 and also in well B1, which would serve as the control well. Then, the gyrase serial dilution was multi-channeled from row C into row A and thoroughly mixed. This marks the beginning of the gyrase-mediated reaction. Gyrase storage buffer was added to the negative control well B1. The plate was then sealed with tape and placed in a certain temperature condition for 30 minutes. The temperature condition would mimic the environment that a psychrophile, mesophile, or thermophile would inhabit. For example, this reaction was observed in 4 degrees Celsius, 25 degrees Celsius, and 37 degrees Celsius, respectively. At the 30-minute mark, the reaction was terminated with the 2 stops. Finally, 6 axolotl dye was added to each assay well, wells A1 through A12 and B1. The contents of these wells were then pipetted into the agarose gel. Electrophoresis was run to completion in order to analyze temperature adaptation of gyrase-mediated supercoiling by effectively separating the DNA fragments. The gels obtained from these assays demonstrate how gyrase-mediated supercoiling responds to different temperatures as the relaxed plasmid and supercoiled plasmid have varying degrees of mobility within the gel. The results of the gyrase activity assay were visualized via electrophoresis. Each activity assay gel contained a control lane where no DNA gyrase was added to the assay mix, and activity lanes, where the DNA gyrase dilution was added to the assay mix. The bands that appeared on these gels showed the conformation and motility of the DNA plasmid contained within the assay mix. The functionality of the DNA gyrase was determined by the conformation and motility of the plasmid. Plasmids can take on 3 possible forms: nicked, relaxed, and supercoiled. Nicked plasmids have a single-stranded break in their DNA and adopt a relaxed, open circular conformation. This form is not compact as it occupies the largest volume, causing it to migrate most slowly through the gel. Relaxed plasmid are more mobile than nicked plasmid, thus migrating at a moderately faster speed. Relaxed plasmids can either be totally relaxed or contain 1 to 3 supercoils. All of these forms are thermodynamically comparable to each other. Supercoiled plasmid is extremely compact, allowing it to migrate the fastest. Thus, the presence of supercoiled plasmid indicated that the DNA gyrase did perform its supercoiling function. The presence of any other conformation indicated that the DNA gyrase did not execute its role. Gyrase activity assays were run on a 1%/1x TBE agarose gel for 24 hours at 24 volts, then stained with ethidium bromide. For the 37 degrees Celsius assay, lanes 1 through 13 contain the gyrase tetramer at varying concentrations as shown in nanomolar. Lane 13 contains relaxed plasmid, and lane 14 contains supercoiled plasmid. The activity assay performed at 37 degrees Celsius showed that gyrase can mediate the supercoiling reaction at this temperature. It can be observed that a higher gyrase concentration caused the plasmid to go from relaxed to supercoiled form. We expected these results since DNA gyrase thrives in mesophilic temperature conditions. Prior investigations in our lab used an in-house sequence analysis program to visualize differential enrichments of amino acids in hot versus cold-adapted gyrase orthologs. Our investigations suggest certain motifs in the C-terminal DNA binding domain are specific to organism growth temperature. For example, the figure on the left shows a sequence motif in the gyre A CTD of wild-type E. coli. It contains arginine at position 665, leucine at position 666, and arginine at position 667. A cationic, positively charged amino acid, like arginine, was expected in gyre A in order to bind to negatively charged DNA. In thermophiles, we expected more rigid and inflexible amino acids like proline. However, we observed asparagine, leucine, and arginine as shown in the frequency data table on the top right. In psychrophiles, we expected smaller and more flexible amino acids like glycine or alanine. However, we observed quite the opposite with the presence of proline in the frequency data table on the bottom right. As a result, we plan to conduct site-directed mutagenesis of gyre A and further gyrase protein purification to facilitate future temperature testing. Variants to the extremophilic specific motif in the CTD will be tested for temperature dependence. Using a bioinformatics-informed approach to detect local enrichments to engineer gyrase in a targeted way, we hope to increase gyrase's tolerance for extreme temperature. I would like to thank Dr. Schofler, Amber Bird, Taya Littleton, Julia Barnum, and Trinity Martin for their prior research and laboratory assistance. I would also like to thank Larissa Cortez Morales, Simone Dowling, Jory Mosby, Robert Shu, and John Tarpey for assistance with growth condition curation. This work was supported by a Louisiana Board of Regents Research Competitive Subprogram Award. I also wanted to note that this presentation uses a colorblind accessible color scheme proposed by Paul Toll and curated by David Nichols. Lastly, I wanted to thank you all for taking the time to listen to my project. I am truly grateful for this opportunity to present my research. Thank you again, and have a great day.
Thank you all for understanding that, and give us feedback on that, because that was our last minute punt to include her today when something came up that allowed her not to be here. So thank you for that, and we'll share the feedback. So we've made it. It's the end of the day, and Dr. Jordan came back and he did a costume change, so he must be ready for crawfish. I don't know. We invite y'all to come join us for our social. It's going to be just right outside, starting in a few minutes. If you just go out the building to your right in the P Squad. But before we do that, I just want to congratulate the students again for an incredible experience today of presenting your work. I know a lot of hours went into that. And you should be commended for that hard work and the opportunity to present today. You did a great job. Congratulations. I also want to thank our guest Symposium evaluators who are still awake and here, and they've been here all day. There are 7 of them sprinkled throughout the room, so buy them a beer. They're all of age. So let's go celebrate.
Thank you to Dr. Thomas for setting us up from the first inspection.
We did it. We did it. Good job. Oh my God.
So what's like? No, I understood. Actually, I was oh God. Impressed. So, no, it was good.
It's doing well. Two volunteers for every. I say it's but I know that most teachers will just say,
Yeah, depending on what sect you are. Wait, did you present this?
no. I don't know. I think it might be like, yeah, I don't know, yeah. I'm not social enough to be able to figure that out.
I love your bird bag.
So, yes, Ray, who was doing the analytical chemistry part, this stipend in South Carolina.
She asked me a bunch of questions.
Zoe just got a gig doing environmental consulting because she wanted to work for years before. Something more lucrative. They're all extremely reliable. And if you want to email me, I can give you their resumes and CVs and see if you want to.
Yes, give me your email address. I'll send you a friend and collaborator at
No kidding. Yeah.
She's been trying to hire.
Oh, yeah.
First class, I'm sorry, I don't have a card on me.
I don't even know how to get cards.
Well, mine all have the wrong position on them. But there is my email. So if you drop. And then I feel bad that I have a card because I'm a scientist and it's just a box full of entries that I'm giving to other people. Orange used to have something. It's gotta be something like an app, like electronic card. Yeah, give me your vote. But yeah, so three of them are graduating without having signed on the dotted line. Man, you good?
I'm good.
All right.
Just doing everything. Thanks.